Okay, everybody, it's 3 p.m. CET. This is Albert speaking. I'm one of the organizers. Welcome to Battlemesh. And now here's my question to the other organizers. How are we going to proceed right now? Shall we wait for a couple more minutes to give the people that registered also a chance to join the call and set everything up on their ends?
Yeah, I think we can wait a couple of minutes more. We are quite a few people now. We are 30, so it's an interesting number. And we also have the live stream on. So if you'd like to attend the Battlemesh on YouTube, you can do it. We are 11 now. So maybe we can start in 5 minutes or 10 if you are okay with that.
Also, if anyone has problems with his infrastructure, 5 minutes more to struggle.
Okay, so let me fix the slide real quick. I hope that's exact enough.
Is it okay if I turn on my webcam? Just to wave at the world.
Yeah, sure.
Give us more music, Paul, while we're waiting.
My super secret launch playlist.
But remember to not use copyright protected music.
Never. I would never do that.
How much time did you spend in waiting lines to capture this music and play it to us today?
I'm sharing the link on the chat.
And how much time did you guys spend at the hairdressers for today? Interesting question for me.
What? Sorry?
Forget it.
I couldn't hear.
500 euros for this one.
Just asking for the time that you spent having your hair done for the conference today.
None. Oh, we have text file here. Hello. Hello.
Let's shake hands. You're to my left at the moment. I don't know.
But this is all within Europe, right? Where's the rest of the world?
No.
In a different time zone, probably. I know Paul, for example, it's like he said Battlemesh starts at like 4 a.m. in Hawaii for him, so he's probably not going to join us that early.
Oof.
Okay.
But bandwidth-wise and performance-wise, we're doing great, right?
Yeah, in the end, with the YouTube stream, downscaling is very easy.
10 people watching on the YouTube stream. 33 in here. Nice.
Okay, so it's 15:05 already. Maybe not 15:05-ish quite yet.
Am I able to change slides at the moment?
No, but I can make it a presenter. Just a second. Here you go.
Okay. Can I erase the time from my side? I guess so. Okay. So we are about 33 on the Google button and 10 on YouTube. So hello everyone. Let's hope we can exceed the 50, the number of 50. That would be great. So this is just a very quick opening session. This will be just to first of all welcome you all for this virtual edition, the third edition. And how it will work, it's this Battlemesh has been through a long way until we have decided to make this virtual. We have tried to make it work in a person-to-person edition, but it didn't work out. So this year we have been in fully virtual edition. Let's hope it goes well and we can somehow make this work and make the personal contact or the way that we used to make Battlemeshes not so much different as we can. So this will be just 2 days event with presentations, not a full week. We tried to make a small schedule so that everyone could join, and the schedule might have some changes, but to check the updated schedule at the wiki. So there are multiple ways of participating in Battlemesh. We have this big blue button webinar style, where you can put some questions, where you can open the screen to everyone and try to make some face-to-face talks. This will be mainly used for presentations and some interaction between the presenters and the audience. Then we'll have the YouTube streaming, which is just a kind of a backup solution for if this server becomes too crowded. So if, for instance, we have like 100 people. You want to say something?
Just a small GDPR notice. If you don't want your face to appear on YouTube, then remember to not share your screen. Share your camera, and if you don't want the contents of whatever you are saying appear on YouTube, then don't share your microphone, but typing should be fine, and you can use whatever alias or handle or nickname for joining the session on Big Blue Button. Sorry to interrupt you.
No problem. Thanks for the very important note. So then we have some small GT rooms for ad hoc talks. Imagine that you wanted to discuss something outside this channel with an enter, or you want to make some other questions. We can set up different other rooms if necessary, and we can also have some questions on IRC if you'd like. The questions should be asked after the presentation. So the most common is to make after the presentation, where you can open the microphone and the camera and make one interaction during the time slot that we have. Or you can make some small questions during the presentation, but we would like to make as a chat, not interrupt the presentations, because in this virtual, it's more difficult to make a discussion during the presentation. So if possible, we will reserve a certain amount of time after presentation for some discussion. Then we have this 2-day schedule. So we are here in the opening session. We are starting now. We have this like 20 minutes just to say hello and set up everything. And then we have some talks until 6 p.m. And then we have a wrap-up session. So this is, for today, is quite a quick schedule for today. We'll try to make it on time. And for tomorrow, we have some more talks. We also have some lightning talks. And there is a free slot if you'd like to join, just like 10 minutes to make a very quick presentation. And yeah, finally, I'd like to thank our endorsers, and also Gifinet and EXO for hosting this Big Blue Button server, which is very important. Otherwise, we couldn't make it. And yeah, we are the local is quite a large team. It's Albert. Just say hi, and then we have Claudio, and it's myself and Hulk, Marek, Paul, and Pedro. So we will be around these days. If you need some help, you can just send us an email if you are not. If something is not working, just shout out in an email. And thank you all for participating. So this is just a very quick opening session. I don't know if you have some questions or some other suggestions before our first presenter. We still have a couple of minutes, like 10 minutes or so. No? Okay.
As a general
So
comment,
maybe
I find it funny that we. Oh, I have an echo here. I find it funny that we still call ourselves the local team, because right now there's nothing local.
the virtual team.
I'm local at my place anyway.
We're local to the internet.
So everybody who wants to participate has gotten links. Nobody's asking for links anymore.
I don't think so.
Everybody seems happy. Okay.
So maybe we can move on to the first presenter.
I just started a chat with Philipp, and he's one of the presenters for the first talk. And Philipp, if you are ready, then we can just splice in your slides and you can start talking. And since you just asked whether you can switch presenting, while you present, yeah, sure, you can do that. And if it doesn't work out of the box for you, then you just ping one of the organizers or one of the administrators in this big blue button room. If you look to the left, then you'll see this list of participants, I hope, and persons with a square-ish icon, they are administrators. And we can grant and revoke presentation rights to you. So if you're fine, then maybe let me just switch to Xflip's and Paul's slide deck. Let me mute myself.
Is it working? Okay.
Sounds good to me. Okay, I'll stop my camera while you present, and Xflip and Paul, you are free to choose whether you want to share your webcam images or just click through the presentation or do whatever. And give me a sec. Who of you wants to go first with presenting? All right, it's Xflip.
Okay, yeah, thank you for the nice introduction. So I'll wait one more minute until I've got the presentation rights. Yeah.
Here you go.
Nice. All right, yeah, thank you very much. My name is Philipp, and I'm here with Paul. And so we want to talk a little bit about our journey on how we upgraded our routing protocol in our local v13 community. And yeah, let's go ahead. So first we want to tell you a little bit on where we are and who we are and what we're doing. And next we want to tell you on like why we even had to upgrade our routing protocol. Then Paul will tell you a little bit on what we made for plans and what different approaches we had to look for and what strategies you can follow. And in the end, we want to tell you our story on how we actually did the migration. So where we are located almost in the north of Germany, close to the Baltic Sea. We have a medium-sized v13 community with about 250 nodes, and we have about 400 simultaneous users at peak and 10,000 unique devices per day. And Paul and I are still quite new to v13. We joined like a year ago or something. So as a little disclaimer, most of the things were learning by doing and experimenting a lot of things. So about our infrastructure setup, we have our firmware based on the Gluon framework. We use 11s for meshing, and we use the Batman Advanced for routing. Also, because we're in Germany, we have this thing called Störerhaftung, which makes it really annoying for people to offer their Wi-Fi to other people if they don't want to be liable. So we use gateways to route the internet exit traffic through them. And it's also nice to have the gateways because we can interconnect all of the mesh clouds that don't have a physical link, all together. And that's why we use the fast detunneling, and also having the gateways that makes it possible to have like this a little bit central infrastructure to support our auto updates. So here's a little diagram on our infrastructure. I'll start on the bottom. So we have here, for example, 2 mesh clouds. And each of those clouds is one of the routers which has an uplink to the internet. And through this internet connection, it can contact one of our gateways. And there it can open the tunnel to the Batman interface, which will then also do the routing. And the Batman interface is connected to a virtual bridge to the rest of the network infrastructure in the gateway, and that then manages also the internet exit. And both gateways are also interconnected by another tunnel. And that's our basic setup we've started with. So why do we even have to upgrade? Isn't everything fine with our Batman Advanced? Well, it's nice and working, but it's a version from 2013, and we are on this compatibility level 14, which is still a little bit old, and a lot of things happened. And so because they changed the compatibility level. Both versions are incompatible, as the name says. And if you have one node with compat 14 and one node with compat 15, they can't talk to each other. So also the Gluon versions, which are now coming up from 2019, don't support the compat 14 anymore. And yeah, that's why we had to upgrade. Also, there's some nice new features in the newer versions of Batman. They now support these TVLVs, which don't break the compatibility anymore so often. Also, there was some optimizations in the ARP cache, improvement in roaming, and soon there are also coming some multicast optimizations. And we also had some problems with the old command line tools. They didn't work so well. So we are now really happy to, that we did the upgrade and can do better debugging and work with the new versions of Batman. So then Paul is now gonna tell you a little bit on how we did the planning. And I think you can give them the presentator rights now.
Yeah.
Can you hear me? Yeah.
Yeah.
So let's start with what do we actually want to achieve. So some people here in Lübeck use Freifunk as a primary internet access. So therefore, we definitely want to reduce the downtime for them. This is probably one of the highest priorities. Also, the migration should be, or the update should be completely automated, since a lot of users don't really have any technical knowledge on how the node and the Freifunk routers actually work. And to make our lives easier, the testing should be very easy. All of our current monitoring tools like Grafana and our node map, where all the nodes are shown, should be available and reachable from both networks. And one other thing we want is that clients from the Batman 14 network can reach clients from the new Batman 15 network, so we can smoothly transition them. So what are the challenges? We definitely want to avoid setting up complete new monitoring. Most of it is fairly new, and we just set it up this year, so doing everything again would be just very annoying. We also have an own AS, and every client device has its own public IP addresses, and some people here use it to self-host things like a personal cloud or something. So this also should keep working during the whole migration. And probably the most important thing is that we don't want to cut off or lose any nodes at any cost. As I said, most people don't have any really technical knowledge, don't want to bother about fixing their node because an update breaks them. So we thought we can split these problems into two separate missions for us. First one is to find a way to set up the backend infrastructure to the new protocol so we can use it simultaneously. And the other thing is on the firmware or node side, that we have to find a way to upgrade all the nodes safely so we don't lose any nodes. So now planning the infrastructure. What quite interesting, so the two Batman versions are the same kernel module, so we cannot load both, cannot be loaded at the same time on one server. So therefore we needed separate gateways for the Batman 15 network. So even if we don't want to replicate everything and avoid redundancy, setting up new gateway is kind of unavoidable. But actually this came pretty handy for us because our old gateways were slightly out of date and nobody really wanted to touch these because never touch a running system, and especially if it's Arch Linux and not updated for 3 years, and no one really knows how it works. And now there's a question how we actually connect the two networks, the Batman 14 and the Batman 15 network. One idea was to use a layer 3 approach, which means that everything for the new network goes into another IP subnet, and then we just route everything back and forth. or the other, maybe more naive approach is to bridge everything directly on layer 2, just on top of Batman. Yeah, so this is the infrastructure side. On the firmware side, as I mentioned, as I mentioned, one major difficulty is to not cut off nodes, and here's a small example how this would look like. So there are 2 nodes and one mesh cloud. The upper one is providing the internet uplink, and now it decides that it wants to update its firmware. And this upgrade contains the incompatible Batman, the new incompatible Batman version, and suddenly the 2 nodes can't communicate anymore, and the lower node can't download the network anymore, the firmware anymore, and it's cut off from the network. So, what are the challenges to do a safe update? One important thing is to I think someone in my house triggered the fire alarm. Interesting. So what are the challenges to do a safe net update? So one important thing is timing. The output data in Gluon decides based on the date and time whether it should update or not. This led to some issues in the past. Also, nodes need a sufficient amount of bandwidth to get the actual firmware. So on a bad wireless link with a really bad link quality, the download can just time out and time out again. So we need to make sure that nodes get enough chances to download the actual firmware. And even if the auto update is safe, it is enabled by default, there are still people who think auto updates are kind of evil and disabled or deactivated. And now to the strategies. The first one is to do more of a systematic update. This was done by the v13 community in Kiel, and they developed some specific tools for this. So the basic idea is that you specifically decide which node is allowed to update and which not. So you would start from with updating the outer nodes with the longest network path to the firmware server, and continue this until there's no node left. Another very cool fallback mechanism they developed is the so-called meow or mesh independent auto updater, which allows nodes to communicate with their neighbors directly on the link layer. And they can ask their neighbors to download the firmware for them if they don't have an internet connection themselves.
Sorry to interrupt you. There seems to be a fire alarm going on in the background. Is it in your place? Are you?
No, it's not in my place. It's a neighbor. This is very annoying.
Okay, just checking that you don't need to run for chapter or anything.
Yeah, no, can you? Is it too loud or? Is it
no,
okay?
it's fine. We're not sure if you hear it with the headphones on. But
yeah, I can hear it.
Sorry to interrupt.
No, it's fine. So back to the topic. So how we actually did the upgrade. So we decided for multiple reasons to go with the layer 2 approach for our infrastructure. So overall, it's just easier to do with our current setup. So as you might know, Batman and so our mesh network is basically a giant layer 2 switch, citywide switch. So bridging it to just another network will probably just work. Also, this approach is completely transparent to the IP layer, and hopefully most of our services just keep working and are available to both networks. And another important reason was that at the time we only had one gateway which had proving for our autonomous system. So in order to keep it running, everything we needed to set up. First we need to find a new peering, and then we have to configure it. And routing and especially BGP is a very big topic and nothing I would do like overnight and it just works the next day. So we don't want to touch the current working BGP setup and just postpone this problem. And on the firmware side, we went with the already available Gluon tools. we already used them to upgrade from IBSS to 11S, and it worked pretty well. It also has a built-in fallback mechanism, which was important to us. So if some nodes don't have the correct time or get cut off, there's still a mechanism so they can switch to the new version. The downside, on the other hand, is that this requires very good planning, and once the firmware is built and compiled, we cannot make any changes, so it's very static. And as I mentioned, we had problems in the past with this. Yeah, on the infrastructure side. So how does it? So one day we were like thinking and planning this, and we had just the idea, so like do it on the layer 2. And we just took like 2 nodes, one running Batman 15, one running Batman 14, and we actually just physically connect them on the client ports. And it worked surprisingly well. So most of the things just worked out of the box. The nodes appeared on our network map. We could see the statistics on our Grafana. So it seems like it would work pretty well, but there were a few issues later. So this is how this whole setup would look like. We now have 2 gateways from our neighboring communities, 5 from Hamburg and 5 from Ostholstein. And the green gateways are running Batman Compat 15, and the other one running Batman 15, and they are connected via a fast VPN tunnel. We call it the migration VPN. Yeah, and if now a client from the Batman 14 network wants to send a packet to a client from the Batman 15 network, the packet travels to the old gateway 1, leaves the mesh, and is sent over to gateway new 2, where then Batman Compat 15 takes the package and routes it to its final destination. So, as I mentioned, there were some issues. Interestingly, the first one was more like a layer 8 problem. When the old gateways were set up, there was almost like no documentation written, or at least we could not find it. So basically, we had to reverse engineering a lot of the stuff and just look at the configurations. And we also did not really knew who had access to some accounts, like the BGP peering provider. So it was a bit annoying. On the technical side, there were multiple issues, for example, with the MTU. On the migration VPN was not set up correctly. This led to some confusing problems because the ping would just came through, but not a whole TCP packet. Yeah, and also with DHCP and NVP there were some problems. So one DHCP problem was that some requests got answered by an DHCP server from the other Batman network. And the reason for that is that we rely on a Batman feature called just gateway feature to run multiple independent DHCP servers on one network. So this feature allows us to mark a node as a gateway, and Batman then routes specific broadcast packages to only the nearest gateway, where it then leaves the mesh. And normally this is not a problem because there are no other VPN tunnels. And the DHCP request is only answered by this one gateway. But now, since there is another VPN tunnel, the package leaves the Batman interface and also gets broadcasted to the new gateways. So to solve this, we simply blocked DHCP. Another very weird problem was that at first incoming packages were not routed into the mesh, but only after a few hours. Executing IP neighbor shows a lot of addresses were like incomplete. So it was something related to NDP. And it turned out that NDP uses multicast under the hood, which might be a problem since Gluon blocks some multicast traffic, and there are some optimizations in Batman to reduce the overhead traffic that comes from multicast. So eventually we disabled multicast snooping on our gateways, and this fixed the issue. So eventually we just blocked DHCP, and also some ICMP types like redirect or router to advertisements. Yeah, on the firmware side is Philipp going to tell you how it worked.
Yeah, exactly. So for the firmware side, we have two major things that we want to do. First, we want to build a new firmware with a new Batman version and to get it to the nodes. So we have a lot of experience with our auto updater, and that's what you use to get the firmware to the nodes. And secondly, we want to have to switch all of our nodes at the same time to this new Batman version, and that's a tool from Gluon we use is called Scheduled Domain Switcher. So first, very short about our auto updater. It's a central update server that hosts all of the firmware files, and the nodes regularly check at night if there's a new file, and if there's a new firmware, they also check a so-called manifest file, which contains signatures and checksums of the firmware. And it's kind of an authenticity feature, so that at least 2 signatures are required for the upgrade. So I cannot say on my own I want to make a new upgrade. I also have to ask Paul to sign off for the new firmware. And another nice feature on the auto updater is that it allows incremental rollouts. So we can say on a time span on 7 days, we want to update every day like 30 nodes. And so if there should be something wrong with the firmware, we can stop it at some point, and we didn't lose all of our nodes. But on the best case, we never lose any of them. So to explain the scheduled domain switcher, we first have to talk a little bit about the Gluon configurations, the so-called domain. And first there's a regular site.config, which configures most of the default variables. So more the general stuff like the community name and the Wi-Fi channel. And then there is for the network specific stuff, so-called domains. And many communities use that to split up their layer 2 network in multiple smaller networks. So then they have different domains, for example, for the different parts of a city, and then give those different prefixes. So route between those smaller networks on layer 3. And these prefixes are then configured in the domains, and the domain can then be chosen in the config mode when the node is set up, or via SSH on the UC. But you can also use these domains to configure the routing algorithm. So you can say, okay, I want to use Batman Legacy or Batman, and you can switch these domains also on a scheduled time basis. And that's what we used. So here on the left, we have like the default domain, which uses the old legacy version of Batman. And then we want to switch at a certain time to the new configuration, the new domain with the not legacy version of Batman. So the scheduled domain switcher is a Gluon package which can be added to your site. And it contains the target domain and, oh, hello. So the domain it should switch to, and a switch time, so a timestamp at when this will happen. So as you might already see, this requires very good planning, because this timestamp then is in the firmware. And so the node then regularly checks if this time has passed, and if the time passed, it will then do the switch. And there's also a fallback mechanism where the node regularly pings a list of targets, and if it realizes that it's that the node is offline for an amount of time, here 120 minutes, it will then also do the switch. This is useful if the node might have a, I don't know, wrong NTP server, wrong time zone or something, and if it misses the date to switch then and gets offline, it then will also switch after a certain amount of time to the new domain and doesn't get lost. So as I already said, it requires pretty good planning because the timestamp is then in the firmware. And on the upper image, I don't know if you can see it very well, this is our normal release schedule for an update. So we would have like, so you can see the distribution of the firmware here. and the blue one is the new firmware. So with like 7 days of beta phase, we have like 30 nodes or something, and yeah, test the firmware before we do a stable rollout, and then have like 7 days of a stable rollout. With the scheduled domain switch, we're going to have all nodes to switch at the same time. It doesn't make very much sense to do this beta phase because nothing happens in the beta phase because we want to switch all of the nodes at the same time. So we cut that down to 1 day, and after we built the firmware, tested a little bit with it, we then signed it, uploaded it to the server, and then just did 1 day of beta phase to see if it breaks something or if the node stays online. So this is now this image here. And then did like a longer period of incremental rollout and waited even a few more days because there's always some stragglers nodes that are, I don't know, offline for 5 days and or didn't have a good quality, link quality to download the firmware. And yeah, then you have to wait for the domain switch. But first, I want to talk about one minor problem we had in the time period of the release of our firmware. So we have this nice Freifunk installation here at the Julius Leber School, and it's like a rooftop installation of some nanostations, and it doesn't have an own uplink to the internet. So there are only uplinks here, here, and here, and they are over 1 kilometer far away. So sometimes the link quality is like really bad. And so we were in this scenario that we already rolled out the stable release. So some of the nodes at the US Leber School downloaded it and already upgraded to the firmware, and some didn't because they weren't in the rollout, or I don't know, the link was not good enough to download. And so what happened then is that one of those uplinks died, and I think the other link quality was also really bad. So they was offline for like more than 2 hours. What was the time we set the switch after offline minutes? And then the nodes with the new upgraded firmware switched to the Batman 15 configuration domain, and the others who didn't already upgrade the firmware or couldn't download it yet were then lost in a way. So Paul and I did a short drive-by and check for it, and upgraded the others manually. And it wasn't too big of a problem because, as already Paul told about the Kiel approach, we could still have hopped from one of the nodes to the others via 11s on the lower layer. But because the link quality was so bad, we decided to just drive by directly and do it in that way. So there's 2 lessons learned from that. So I think it would have been better if we did less days of the incremental rollout so that there's not such a big time span in which not all of the nodes have the firmware. And we definitely wouldn't set the switch after offline minutes to a much longer interval next time. Then also this probably wouldn't have happened. Yeah, so what did we then do? We did nothing. So we just had to wait for the day we set the timestamp to. And so we met at the local hackerspace and watched some Batman movies and had a little party, and then waited until it's 10 o'clock. And well, as you can see in the plot, we have here now the domains that the routers have chosen. So first, there were only a few nodes in our new Batman 15 network, and most of them had still the default domain. Then they started switching, and well, what happened then? So there was a little moment of excitement where we thought we lost really all of our nodes, or we did something terribly wrong. But well, after 10 minutes of debugging, we realized that we actually lost our statistics server, because that statistics server is also part of the mesh network, and it sits directly behind a Gluon virtual machine. And there was some temporary configuration which wasn't permanent and got lost during the reconfigure. And so after some quick fixes, we were back online with our statistics and saw the good news that everything went very nicely, and all of the nodes switched to the new configuration, and we didn't lose many. So yeah, thank you for your attention and thanks for the Battlemesh Augur. So thank you for having us. And if you have any questions, please go ahead. I think there's some more time.
Yes, indeed. Thank you very much. Great talk. Pretty substantial chunk of work that must have gone into this. So may I just ask a very easy question? So how long a period of time did all of these activities span?
I think it's more than a year or something we've been working with this. So actually, I think when I joined Freifunk Lübeck here in an active matter, I already heard Paul talking about setting up new gateways and struggling with that. So that was the thing I think that took a lot of time to figure out how these gateways actually work. And I think then the later part of actually building the firmware and doing the rollout, this was more like a month or something, but like all this layer 8 problems and this work beforehand was, I think, almost a year or something.
Wow, and may I ask, could you slip this in between the cracks between studying and working, or how did you like time manage this? I mean, at least 2 people were involved, it seems, and from experience, it gets more complicated the more other people you get involved. So how did time management and organization work on that end?
Yeah, Paul and I both study here at university, computer science, and it was, yeah, quite a lot of our free time, but we also had some people who helped us a lot and explained us so much stuff, so that also really helped. And yeah, so we were lucky that we didn't have the pressure to do this until some certain date. We were just like, okay, we want to do it someday so that we can go upstream with Gluon again, but it was more like a hobby. So
yeah, many thanks to Linus or TX for explaining a lot of stuff to us. It's really helpful.
Okay, very cool. Yeah, questions from the audience. You are free to either use your microphones. Please just post I don't know, say an exclamation mark in the chat so that I know that you would like to speak. And if you don't want to speak up, then you can just post your questions in the chat. And there are a few thank you messages already from San and from Bastian Pitorf. That was great, and thanks for the talk. And Marek, I think, has the first question to you. Marek, go ahead.
I was the fastest. Yeah, thanks a lot for the talk. Very interesting. I'm one of the Batman developers responsible for this compat change. So thank you for enlightening us. I'm curious if you have general tips and recommendations for other community networks, because upgrading, from a certain experimental version to another newer version of the same protocol, or even a very different protocol, are questions that come up on a regular basis. And I think you're one of the few examples I'm aware of that managed to pull this off remotely. So the question here is, what are your general lessons learned and recommendations for other networks, community networks that want to also migrate, but maybe not necessarily Batman, or not necessarily the same, from version 14 or 15 of Batman, but like in a more general fashion.
Okay, I will go ahead, and Paul, maybe you can just say something if you like. You can also say something after me. Yeah, thank you very much for the question. I think the tools coming with Gluon really helped us because we could already have some experience with the auto updater and with the domain switch and other changes. In general, I think, yeah, we did a lot of planning in beforehand, and the thing that we bridged both networks really helped, because we had for a long time a nice test setup where we experimented with the nodes in the newer mesh network. So that was, I think, yeah, one really good thing that we had this test setup without any extra infrastructure to maintain, and we could be sure that in the new once we switch, everything will work, because it's still the same infrastructure in a way. So having the both networks bridge was really nice for that. And yeah, I think that's as much as I can say.
Yeah, I would also say that it's really helpful to change as less as needed with the whole infrastructure, because it makes testing way more easier. So in our case, it was the BGP thing, and we maybe would not know if now some pre-ring BGP stuff is broken, or the firmware is somehow broken. So yeah, I would suggest that it's to try to do as less as possible, or to change as less as needed.
Thank you very much. There is a question on the chat from Bastian. Maybe I missed it. How many nodes were involved?
Yeah, so we currently have 250 nodes. Yeah, around. Yeah, so yeah, 250 nodes.
Hi, I'm Bastian in person. Another question. How many people you had to contact before or after the upgrade? So are there people in your community which maybe have switched off the auto updater, or maybe were on vacation or something like that?
Yeah, thank you very much for the question. So yeah, indeed, there was some people who were like had their auto updater turned off and were like on a, I don't know, super old version. And so it was like, I don't know, 4 or 5 people we contacted directly. Luckily, most of them had like an email or something on in the contact field. So I think that worked quite good. And so we had our old gateway still running for a few more weeks. So it was then still possible for old nodes. So if somebody would have been on vacation for like a month or something, it will still have been, they might still get the update due to the old gateway. And then, I don't know, a few weeks ago, we then shut that off. So I hope we didn't cut off many nodes. So yeah.
So this was also a reason why we wanted to run both networks simultaneously and somehow connect them. Yeah, because of this scenario that an old node connects to the network and can get its new firmware.
Thanks a lot. This was really great.
Thanks.
All right, I invite further questions from the chat. The session is running for 10 more minutes, if you like. San has a question. For the speakers, did you consider using dual boot or dual firmware with a post-upgrade confirmation step? And do you think that it may be valuable for your use case? We are doing dual booting plus confirm with LibreRouter networks, and so far the experience has been good. No full mesh upgrade to support yet. We are starting to work on it, so it would be great to share ideas, implementations, insights. Thanks again for the talk. So you see the question on the chat as well. Comments from your end?
Okay, I haven't heard about that before. It sounds really interesting, and I'll definitely take a look at that. So for my side, no, I didn't consider it because I didn't knew that would exist. So that might work as well. I don't know. About the glue-on domains, it's also some sort of dual firmware, but more like on the smaller thing, like more like in the configuration just. So I think during the switch, it actually also does like a reboot and configures a lot of stuff according to the new domain. Yeah, that approach sounds also really interesting.
Thank you. Comments from Paul on that aspect? Or maybe not. I don't know.
Yeah, I think Philipp summarized it pretty well.
Okay, cool. I didn't actually realize, and this is going back to San, that there are routers that have dual firmware. I know this from like Android devices or yeah, smartphones, basically. But it's interesting to hear that you have this kind of safety feature if you botch up a firmware update for routers as well. Thanks for the comment. So there are some more typing on the chat. You have 6 more minutes to type. I think that's a comment on what San wrote from T_X. Sounds interesting, but it might be difficult with the many 4 MB flash routers we have at Freifunk. Okay, so that seems to boil down to the choice of hardware, really.
Can you talk about a little bit what is a typical setup for a Freifunk Lübeck node? What is a typical router in your community?
So yeah, typical router or typical node is yeah, Gluon as a basis, and then our specific site configuration, which is yeah baked into Gluon at compile time or build time. And the node itself runs a fast VPN tunnel to one of our gateways, and also have a 11S interface to connect wirelessly to other nodes in the neighborhood. And on all these interfaces, there's running Batman as the mesh protocol. So yeah, everything, the complete whole network is like a giant switch, yeah, completely citywide. So if there's one network at the north from the city and there's one node at the south of the city, it still appears that these are directly connected via an I don't know, Ethernet cable or something. So yeah, these are basically the two things on the router, the fast D tunnel and the Batman, and of course a lot of other stuff like out-hop data, schedule to main switch, and so on.
Can you say something about the hardware or the router models you are using? So in terms of flash size and RAM size?
Yeah, Philipp, do you want to?
Yeah, so we have still quite a lot of legacy devices. So the TP-Link 841, I think is it, was for some time when Freifunk Lübeck was growing very fast, very popular. So we have a lot of these 4MB devices, and we are right now trying to bring more people to also like dual Wi-Fi devices and devices with more flash and RAM. But yeah, that's the thing that we will have to deal with in the next years as well, that some of those devices won't get support from Gluon anymore.
So what's at the moment your good advice if somebody wants to buy a new router? What is the new star on the router sky?
There's been the new Fritzbox 4040, I think, which is kind of neat. And I think there's been devices from GLINet who also have shipped with OpenWrt. That's also pretty neat. But yeah, I don't know so much actually.
Yeah, we have a recommendation tables on our wiki. So on wiki.lübeck.freifunk.net, we have a list with recommended devices that we think are yeah, good devices and more or less future-proof.
Thank you very much. It's not getting extremely late, but it's getting kind of late. So if there is a pressing last question from the audience, I would like to invite it right now. Otherwise, we'll go into a short break, and in a few minutes' time, Max Mehl will be online. He's from Free Software Foundation Europe, and he'll give a talk on RED. So I see people typing. Please don't go away just yet. Okay, and you can read it. Applause, kudos to Freifunk Darmstadt, especially. Okay, here you go. Ango WRT claps. Thank you very much for coming. Great talk. I hope you enjoyed it. And in case you are interested, there's also a Jitsi meeting room. I'd like to ask the fellow organizers to just post the link in the chat. And you can go there, continue the discussion, discuss about something else, or stay here and enjoy the next talk, which will start in a few minutes' time. And here you go. Klaus just posted the link to meet.giphy.net/w/Battlemesh v13. Here you go. Okay. Thanks, Philipp. Thanks, Paul, for your very nice talk. Hope to see you next year in person. I don't know. Let's see how it goes. And yeah, the next talk will start in like 2 or 3 minutes.
Yeah,
Thanks.
thank you very much for having us.
Wow, we're so on time. Like a clock.
Yeah, in my first Battlemesh, I think we started about 2 hours after the schedule.
What's the schedule? Max, can you hear us?
Yes, I can hear you.
Cool.
I'm just setting up. Do you hear me well? I don't have my normal microphone here.
Loud and clear.
Excellent.
Beautiful.
That's how I like it.
So maybe you prefer someone else to introduce you shortly. I can do that if you want. Or if you want to introduce yourself, it's also fine.
I don't know what you want to say about me, so.
So we asked you because you've been quite active in this lockdown history, as far as we know, right? It's a long, 2014 it started or something, I guess, because it's called 2014.
Yeah, we got active in 2015 actually, when we noticed it, what happened there.
Yeah. So yeah, thanks for showing up and letting us know what's the current status and what should we sort of prepare ourselves in the future to come.
Okay, yeah. So as you already said, first of all, thanks for the invitation. It's an honor to be here finally. I've been asked many times to come to Battlemesh, but never was able to do so. And yeah, so as you already said, asking me was quite spontaneous, so please bear with me. The slides I just prepared in a few minutes are not really comprehensive. And yeah, but my main idea is to give you all a small idea of what happened there, what happens there, for those who haven't been following the topic, and to save some time for discussions and questions, because I think I can imagine that there will be many. So the whole thing is called Radio Lockdown. That's how we branded it. Actually, it's called Radio Equipment Directive. So this is an European directive from 2014, as the name says. And yeah, it went through Parliament and also got adapted by all EU member states. So we cannot do anything about this. So what's inside of this directive? It's basically just a successor of the old RNTTE directive. So basically handling all kinds of wireless devices and so on. And there's one part in it, only one article or one sub-article actually. That's why we didn't really figure it out when we first saw the directive. This is Article 3.3i. And in there, this is like the tricky sentence. It's radio equipment shall support certain features in order to ensure that software can only be loaded into the radio equipment where the compliance of the combination of the radio equipment and the software has been demonstrated. So that's complicated text, but this is quite clear if you read it a few times. So radio equipment, that means the manufacturers who want to put the radio equipment on the market, their radio equipment have to ensure certain features that make sure that the radio equipment, with a combination of the software, that this combination of software and hardware does not break any radio regulations. So that means does not send in frequencies it shouldn't send, like 5 gigahertz with this weather radar, or I don't know, listen to a police communication, or not more than 100 milliwatt in Germany, like for the Wi-Fi and so on. So manufacturers have to make sure somehow that the software that is loaded onto their devices does not break these rules. So basically, this is like if you tell knife manufacturers that they should somehow prevent people to kill someone with their knives. So right now, it is the case that, of course, the manufacturers with their software have to comply with the radio regulations and have to prove that. But if I'm able to change the software somehow, legally, illegally, doesn't matter, and I do something illegal, then I'm, as a person, am responsible for this, and not the manufacturer per se, like from the very beginning. Of course, there might be special cases, but yeah, that's the complete turnaround of the whole responsibility. So this is already done. What's still unclear is which devices will be affected. So this could be any wireless device, no matter whether only sending or only receiving or both, no matter the frequencies, but it's likely that it will be a subset of devices. And this is still completely unclear. Like, is it Wi-Fi routers? Is it GPS receivers or senders? Or never mind, Bluetooth, could be anything that has something to do with radio waves or with wireless communication. So, what are the potential threats of that? There are many, and for the sake of time and time for discussion, I want to keep it short and only limited to the threats for projects like OpenWrt, which you will be certainly interested in. And there might be a number of reasons, like or threats, if the targeted devices also contain things like OpenWrt. How can you people, or how can the manufacturer prove compliance? Of course, they can do it for their own software. They put it in some radio labs and test it with expensive equipment. But how can they do so if they want to support you? Like, they want to support a certain version of OpenWrt. How can they prove that? Like, they can load it onto their devices. That's all right. But how can you do that? I mean, I'm a little bit afraid that manufacturers become gatekeepers of their software, or of the software that can be loaded onto the devices. So it's quite unrealistic, perhaps, that all manufacturers will actually want to or be willing to support projects like OpenWrt to be certified for their hardware. Then it's also likely that manufacturers will close down access to radio parameters of the software. So even if software like OpenWrt can be loaded onto a device, this might happen in the sense that, well, it might just be the user interface, or I don't know, certain other software that does not interfere with somehow radio parameters or so. And even if, how can a manufacturer certify, or how can anyone certify that this is also true for updates? Like OpenWrt ships quite a few updates, has beta versions and so on for a number of devices, and the same goes for all these Freifunk, Funkfeuer, customized firmware for cities and so on. So is that realistic, and how much will it cost, and who will actually pay for it? As I said, I don't see the huge incentive for industry to help free software projects like OpenWrt to enable this. And of course, there are many other threats on our website. I think it's in the talk description, in the wiki. There's the link to our website. There are many other threats for security, for user freedom, for free software in the end, also for license compliance, but also for the environment, because we cannot reuse hardware anymore, potentially, if there's no updated software by the manufacturer anymore. And as Paul already said, the whole thing started in 2015, for us at least. We were one of the first organizations who spotted what's happening there. And it started with an expert group, like I'm not talking from the official steps, basically. So there was an expert group, and we applied there, wanted to be there as FSFE and also some other organizations. Turns out they have quite unrealistic thresholds for becoming part of this expert group, at least from the civil society. So we weren't able to be there because of administrative reasons. Officially, we were no European organization. And but yeah, we got some word of the expert group. In the end, they met a few times, sent around a lot of documents, and yeah, nothing happened basically. There were a few consultations. So there was an official feedback period, I think March last year, with an overwhelming, I would say, negative feedback for the Commission that they should get rid of that and in the end support free software and spare projects like OpenWrt. So not activate, I would say, most consumer devices for this directive, so that these are excluded. There has been an expert consultation and also just recently a public consultation, both for which we do not have the results yet. So this is, again, quite interesting. The 2 months after the consultation, there are no results available online. And yeah, so the road ahead is officially that they wanted to have the whole thing adopted. So basically defined all the equipment that is affected by this directive or by this certain article, 33i. They wanted to have this ready in the 3rd quarter of this year. So obviously that failed. We have no idea when the draft act will actually come. So basically the draft for the affected devices, whether there will be another consultation on the selection of these devices specifically, and when the actual adoption is planned for. As you can see from what I said and from my emotions, this is an uphill battle. I mean, I'm in this thing since now 5 years, and I don't have the feeling that we are working together with the European Commission on this, and yeah. So this is really hard, and I've also been part of a personal meeting in Brussels last year, yeah, and it was disastrous. Like I got 5 minutes of time to speak there. The rest of the people in the room mostly were industry people who basically said, well, go ahead, security is always good, and well, yeah. So in the end, I have the feeling that the European Commission doesn't really understand what's at stake here. They also do not really understand free software. They didn't understand what the Linux kernel is and what GPL and licenses are. But in the end, they're affecting this. They do not really understand what OpenWrt is, and well, they do not really care for it. On the other hand, all they care about is safety. Like they want to shut access to software down. They also want to do a few other crazy things. At least they said something about app stores for all devices. So basically controlled walled gardens. So people can only install stuff from proprietary app stores and close down app stores. Like all these crazy ideas, I would say. So this is a really hard thing. And unfortunately, it's really complex. So as you've seen, it's a directive and it's a bureaucratic process here with the European Commission, a political process. So this is always complicated. But in this case, exactly, like specifically, it's about radio parameters and regulations and a lot of documents. So yeah, I can understand that this is not really, well, like went deep into the public debate yet, but I think we have to do something about it because as you see, at least I see it and we see it, that yeah, this is a major threat to free software projects. So I want to save a lot of time for the discussion. So just, you want to help with this? This would be great. What can you do? You can join the mailing list. We have one that we started from the very start on. It's quite silent. It became quite silent because many organizations and individuals do not have the time anymore to become active or to chat around and really work on the issue. But I would highly like to welcome you to join this mailing list. I don't think you can really click on the link here in this presentation, but you can download it. It's linked there, or you just type it into your browser. I kindly ask you to spread the word in your communities. Make them aware of this issue. Tell them that this may basically destroy their foundation if this ever goes through and is actually then adopted by the industry. And for the communities, like if you represent a community, please get politically active. Raise your word in consultations if they happen. They are not really quite often, but raise your word. Write emails to the commission or basically to the responsible DG, and yeah, get active there. Write blog posts about it. Collaborate with organizations like FSFE so that we can make this a real topic in the public. If you do not have time, if you're not affiliated with an organization, please support these active organizations financially. Support OpenWrt, Freifunk, FSFE, of course, if you want to. This whole thing, this whole battle goes since 5 years now. It's really hard, and also, as I said, hard for individuals there from different organizations. So yeah, if you can buy them a coffee, become a supporter somewhere, that would be great. And that's already it. So I'm looking forward to questions and the discussion. Thank you.
Thank you, Max. That was great. I mean, sobering, but a nice roundup. So questions. I'm gonna manage the queue. If you want to say something audio-like, then just please put an exclamation mark. Otherwise, one question that Paul was, so I can download Freifunk as an app to my router? It would be nice.
Yeah, that would be the utopia, but I'm more afraid of the dystopia around app stores.
So I have a question. There was a consultation recently, right?
Yes. Yeah, it was called public consultation. Right, I think I still have the, yeah. Post the link in the chat. Completely forgot about the chat. That should be it. So on the left, you can see the roadmap, at least by the commission. And yeah, so there was a feedback period until 14th of September this year. We do not have the answers yet, so we have no idea about how many people participated. In the last feedback period, which was more or less, you can write 4,000 characters on the topic, and this time it was more like a real survey. The last time it have been, I think, 270 replies, as I said, mostly against the plans by the commission, which was quite amazing. But yeah, no follow-up on these. I also participated there, got no reply. But at least we know that people care about this. But yeah, it seems that the commission does not really react because the last public consultation, so from September, yeah, the questions were completely biased, in my opinion. So not really down to what it's really about, but more or less like, what is the industry? What do you estimate as the industry impact and so on? So it's more like, yeah, questions that do not really matter from our perspective.
Okay, thanks. Hauke, do you want to go next?
Yeah, in the beginning, there's also something similar happening in the US, I heard. Do you know what is there, the status of the FCC doing similar things?
That's a really interesting question. It seemed for a long time that the FCC actually started. So they had a similar thing, but only for Wi-Fi, so for 2.4 gigahertz and 5 gigahertz. And then that the European Union actually reacted on that, but actually it's been the other way around. the European Commission or Europe or people in the European bodies were afraid or saw that there was like these interferences with the radars on 5 gigahertz, and yeah, that there have been so many issues about these, and therefore they wanted to regulate that. But in the end, yeah, we have now this article which is complete and not really yeah, down to what it was actually about, like weather radars and how to regulate these. The FCC just reacted on this because, well, the European Union wanted that this becomes a common thing. I'm not quite aware of or sure what it's now with the FCC, but I saw that there has been a lawsuit against a router manufacturer, I think it was TP-Link, which and a court fined them with, I think, $500,000 because they restricted the upload of alternative software on their devices. And so in the US, it seems to be much freer, a much freer market, so that it's more possible to upload software on this equipment. But on the other hand, the EU is a really large market. And so if this whole regulations or if this whole directive becomes active or this article becomes active on consumer devices, it will have an effect also on US devices and Asia devices and so on. So I'm pretty sure about that, that it will not only be bound to the European Union.
Okay. Well, Zach asks, what would EU do if this is unsuccessful? Sneak routers across the borders? Or I guess the age of the hardware will start to increase as old things are still active.
I'm not sure whether I understand the question.
I think
You mean with
in terms this whole regulative measure fails, sneak routers across the borders, I think if it fails to
I could say it with words maybe.
Yeah, please.
I was just asking, you know, if the measures to prevent this from passing into law and you know, and being implemented by manufacturers so that you cannot load free software anymore. And as you said, the routers will just be thrown away if you can't update them, you know, into a large trash pile somewhere. What will software communities like v13 and so forth do? Like, I suppose, will they just use old routers, or do you have to carry truckloads of routers across from Asia or something else, or what is the situation?
You tell me. I mean, what's important is that this would only apply to routers that are newly put onto the market. At least that's what the Radio Equipment Directive is. Also, if now this delegated act will be adopted by the European Commission, I'm not sure whether they will have some spare period so manufacturers can react on this. Perhaps 1 or 2 years, could well be. But yeah, old devices will work. Asia devices perhaps, or hack devices, I don't know. But I'm a little bit afraid, like, of course we will find ways around this, technical ways. Like you know as well as I do that there's no 100% security and we can jailbreak basically everything. But I'm from our perspective, I'm afraid of user freedom in the broad masses, more or less. So you can put your software onto these devices. I can perhaps do with good instructions, but I think the benefit of projects like v13 is that everyone can do this. So you buy this device, you follow these 5 easy steps, and you're done. And this is legal. Like, you don't have to buy a device from Alibaba, but you can go to MediaMarkt or Saturn or something else. And like, this whole thing will restrict basically how everyone can gain sovereignty over their devices. And this is what we urgently need. And I would say this is still too little, what's possible, and still too complicated. But this, again, will make it even harder.
Yeah, you were speaking about the US a moment ago. You know, myself and a couple others here are in the US running a network here. And, you know, the situation is that we have, there are many, many models that are US only models. And they have far less frequencies, even beyond a lower number of frequencies than what they could use, even if they did not restrict access to the devices. So you end up with only maybe 4 or 5 channels, including some of the newer TP links. And so what ends up happening for us is we either buy old devices, very old TP links, and so that's not very fun, and it's not very good quality. Or we actually buy international routers from you guys. So if you guys are starting to be locked down, then we will no longer be able to buy international devices. And then of course, if you buy the international one, you can use it with the US rule set. But what the US only ones have the most restrictive, because they don't know what the future is going to be for that chip or for the regulations, where the international ones, they just load the rules with software. And so they have US 1, US 2, US 3, and you can continue to apply a newer regulation or just violate it and use whatever regulation you choose. So, I can imagine it'd be something like that, but perhaps the supply chain will be even less if European lockdown happens as well. Okay, good. Thank you very much.
Thanks.
Bastian, you want to go?
Yes, I will repeat my question because I had some typos. Do you have some tactics, or a feeling what will be a good argument for the guys from the European Union, so that they get an idea of the impact? Because you already said it right. You cannot go deep into technical details, but maybe you must catch them via some money things or something like that. I wrote in the notes that on the one side they throw money on Linux, but on the other side they block working with it. Do you have some idea?
First of all, please send me links where the EU guys throw money on Linux. I would like to see that, at least in this large scale. But yeah, to your actual question, that's a good question. Coincidentally, the whole directive is driven, or this whole delegated act. So yeah, these extra steps are now taken by DG Grow. That's the Directorate for competition, you could say, like growing economy, but also competition. So I would recommend always to use the competition and the economical arguments, like firsthand at least. So you could say, well, we know a business that makes money with using their own software on third-party devices. And what you're doing there is like destroying this business, and coming then with technical arguments why this is the case, like case studies for this. Of course, then or academia is also a good thing. So basically, all these SDR chips, which is a software-defined radio. So a perfect, like probably candidate for those devices that will be actually affected by this directive, because you can do anything with it and only control the software. So yeah, find good arguments from the academia side for this. Or again, case studies, send this to them. The question is, we already brought up all these arguments before, and with limited success, I would say. If I knew perfect argument, I would bring it up anytime I speak about this, but I don't really I think we have to explain it to them with a hammer, and also with a broad coalition of organizations, and optimally also companies or even industry associations. But what we see right now is that most industry associations actually argue, well, not really against it, and that for many companies, it's too complicated, or they say, well, we will find a way around that, or I cannot believe that this will actually happen. And yeah, so this is the situation we are facing.
There's a question on the next expected deadlines that we should be aware.
I don't know.
There's nothing?
Nothing. Like, I have all the information that you have, like the link that I posted before shows the roadmap. They still have in the thing that the commission adoption is planned for the third quarter of 2020, which is already passed. So, well, I have no idea. And actually, deadlines have always been ignored in this whole process. Now also there with the COVID thing, of course they have a good argument that it's a delay, but I have no idea. I have no insights anymore. We are no working groups, and to my knowledge, everything is handled in closed rooms, no public forums, and yeah, as I said, not even the results of the public consultation are public yet. So I'm not really sure.
Have you seen something like that before?
It's hard to compare. To be honest, this is the first time we have such a directive, and also not only the directive, like this is happening in Parliament, but now with the Commission with a delegated act. So for me personally, this is the first time that I'm tracking a process, a political process for this such a long time. And also in this, like, I would say, technical, this technical complexity, I would say. So I cannot really say whether this is normal, but it doesn't feel like this is normal, basically, for civil society. I know that civil society, like FSFE, we have it sometimes hard to get into these committees and working groups, and also in this whole bureaucratic apparatus. Because, well, we don't have so much time as industry associations do, and especially not as much money, which is basically equal to time. So yeah, sometimes for us it's really hard to get into this, but yeah, here this thing, I mean, they have an overwhelming public feedback against their plans, and with the last consultation, all the questions did not really get onto the point that was brought up by so many people in the feedback period in 2019. So my gut feeling is that they are just trying to, delay it and basically do what they had already achieved, that so many organizations said, well, we do not have the resources anymore to deal with this, and so many individuals. So basically just outtime, how do you say it like this, like outtime everyone else. Like they have time, they have the resources, they just wait one more year, and well, then again, it's 50% less organizations caring about the whole thing. This is my gut feeling. I don't have any sources for that.
Okay, FWE asks what kind of lobbying work you can recommend. Is it writing EU petitions or online petitions?
Mm-hmm. I would say let's talk about this together. I think it's time that we come again. I would say we had this already in 2016, that we had quite a good coalition of organizations and individuals. I would propose let's join the mail, or you join the mailing list, and let's exchange ideas. Let's have a call, short online meetings on this, and talk things through and think about good arguments and a good strategy. I don't have the perfect strategy yet. I think it's a mixture of direct lobbying, so writing them, showing them that we still show interest, asking questions about, like, give us the current documents, freedom of information requests, and so on, but also public pressure. So getting the topic in the media, we had it already, as I said, in 2016, that we got at least on Heise and Golem, I think, but afterwards there was nothing, because, well, it's a really complex issue. So I think we have to at least try 2 or 3 different methods, basically, to get the topic on the agenda, to push our topic to the European Commission and so on. So yeah, I think there's not one thing. And personally, I'm not really fond of petitions, at least not for things like the European Commission, because they are not elected in most cases. So they do not really care about the public image. And they are not like these figureheads, like members of parliaments that you can address directly. This is a bureaucratic apparatus. And yeah, so we have, I don't think that the petition is the best way to lobby this. But we can talk about this. I think yeah, that's the most important thing. Raise awareness amongst organizations, amongst communities, amongst the public.
Hauke, you want to go?
Marek asked a little bit. Felix and me were contacted by some guys from some organization, from some think tank, or I don't know exactly what they're called, for this expert interview in spring. And we gave this expert interview. I think it was planned for half an hour and took then 1 hour. And yeah, we talked with them and tried to make them understand the problems we see from the OpenWrt side for this. I hope at least these people understood it, but I don't know how this goes then further. So we got the notes which were written down, but hadn't heard anything later on.
Do you know which organization asked you this?
I can check my mail.
You can also send it to me later. Like
yeah, I can send it to you later.
Yeah, that would be great.
Some Brussels think tank. They said they were the European Commission asked them to do these interviews, and about 40 interviews they did or something like this.
Okay, could well be that there was one institute, like research institute, that was contracted to make a service out of this. I got to know these people in Brussels at this personal meeting that I talked about. Yeah, I have my opinion about these, the questions or the questionnaire that got sent around, but it's interesting that they approached you. That's great. So I would be really interested in more information.
So at least we didn't go over this question, just what do you answer for this question. It was later on a pretty open discussion, and it looked like they were interested. At least after some time, more people joined this call, which was funny.
Okay, cool. Yeah, please send me more. That sounds
okay.
brilliant.
I can send you to you. Yes.
Okay. FWE asks, what does the Purple Foundation think about that?
I think we were in contact at the very beginning of this whole thing, 2015, 2016. I'm not sure, sorry. Never got in contact with these guys afterwards, so I cannot say. But please ask if you have contacts there, please do so.
Any other questions? People are typing. Thank you, Max. Thank you. Yes, lots of thank yous. And I also want to thank you again.
Thank you. Thank you for having me here and the interesting discussion. So yeah, please join the effort. That would be great.
So next up, we're perfectly on time. Thanks, Max, again. Albert, are you around? Because the perfect segue is now to a talk about the actual problem that the radio directive wanted to solve, which is this weather radar problems. And Albert Raffetseder, do you want to show face or?
You've seen it previously, and now my hair is unkempt, so I probably prefer to remain.
Okay.
Camera off.
Fair enough.
Okay.
Please.
Thank you very much. Yeah, this is Albert speaking, and I will give a talk about the thing that I built based on various inspirations, and it's called the Weather Radar WLAN channel map. To give you an indication of what my talk is going to be about, I have this slide here, my talk in one slide. So I'll present this little map with funny little circles in different colors. And it also has, and that's important, so I'm going to highlight it, this little blip in the middle, this pin, and this pin just fixes a position on the map. And once the pin is fixed, you get a list of channels on which you would expect weather radars, that location. Okay, so now you heard my talk, and if you want to know more details, then you can see me talk about the next 10 slides or so, because they will have the details there. All right, so this is the basic structure. I'm going to talk about v13. This is the community network that I'm a part of. I'll explain a little bit about Wi-Fi, also called WLAN, wireless LAN, and weather radars and dynamic frequency selection. And this is the triad where the problem arises that we're going to fix. I'll tell the little story that made it so that I'm here to present this today. I'll show how you can use the map. I also have a call for help, and at the end, I'll show all of the URLs which I deem important. So here we go. As I said, I'm a member of v13. v13 is a do-it-yourself internet association, and we do everything ourselves on all levels. So this is both on the technological level, but also on the societal, and we're also networking in an international way, both with data packets, but also in the way that we join community events such as this one. And the same also goes for all of the network layers. So we try to be active, and we're experimenting a lot on various things, including different services that we run in our community network. This is experimenting with hardware and firmwares. We have a housing chapter, maintenance of machines and services, obviously. Link technologies, this is also a fun thing. And link technologies, you see this in this wonderful, almost hand-drawn figure there. So there's microwave links that join buildings, but there's also fiber links which join the actual installations on rooftops with our servers and our routers. And our routers make it so that we can access the public internet as well. So there's something for everyone there. The technical background of what led me to constructing this map is like that. As you probably all know, wireless LAN is specified with different frequency bands, but none of these bands is assigned on a primary or exclusive basis. So these bands are always shared between Wi-Fi and other services or other things. So in the there's this short list below which lists the frequency band, and there's the 802.11 standard in brackets, and there's a comment as well. The 2.4 gigahertz region or frequency band is pretty overcrowded at most places. 3.6 gigahertz, which is 802.11y, has different assignments across countries, and in Austria the situation is this. They just sold off most of the spectrum to mobile operators for 5G. And for 5 gigahertz, there are a couple of different parts of the band. The first part is for indoor use only. And then there's the one that I highlighted, which is for outdoor use. And again, this is a band that is not exclusively available to Wi-Fi, and Wi-Fi is just one of the non-primary users there. And you have to expect that there are radars, so you need to use dynamic frequency selection, which is a technique that makes it so that you avoid channels on which weather radars work. Lastly, and also live in our network already, there's the 60 gigahertz part of the spectrum. This is 802.11ad. And you have strong atmospheric attenuation there, so the links are relatively short, like a few hundred meters. I think 1.5 kilometers is something like the upper limit until which you can expect meaningful performance. And since the antennas are high gain, these are really like, a friend of mine would call that lasers. But let's just say that they are very sharply focused, so you don't get broad coverage from these 60 gigahertz devices. DFS is called dynamic frequency selection. It's part of an ETSI standard, and you can use that number and the specific clause to look up what the actual DFS operation is. The idea is basically before you can use a channel, you do a channel availability check, so you can you listen on that channel and see if there is someone using it already, and someone in that case means a weather radar. But if the channel is available, then you may use it. And then you perform in-service monitoring, which means you just keep listening for radar signatures while you are using the channel. This works because, oh, sorry, Bastian, can you mute yourself, or shall I mute you? Ah, he muted himself. Thanks a lot. in-service monitoring while the channel is in use still works because you're not sending all the time, but you also need to listen on the channel, since this is just one channel that is shared for all the stations in the same channel. So you can actually keep listening for radar signatures while using the channel, because you're sometimes in listening mode. And if I hear a radar, so if I recognize a radar signature, then I must inform the connected stations that I changed the channel. And then I will change the channel. And there's a certain period of time, which is called the non-occupancy period, where I'm not allowed to use the previous channel, the one that I switched from, the one that I heard the radar on. So I'll leave that channel alone, and I need to wait until the non-occupancy period has passed before I can use the channel again. And the question in schemes like these is, as always, what could possibly go wrong? Well, the radar signatures are different across regions, and they also develop over time. The detection is not always spot on, so there are false positives, but false negatives as well. The transmission conditions and the positions of the sender receiver are unknown. There might be shadowing, so you are not sure to be able to hear a weather radar that's, say, next door, but you are also not guaranteed to not hear a weather radar just because you're operating indoors or operating in the basement of your house. Software or hardware might be buggy, and the same goes for configuration. So it's pretty likely that something goes wrong there. And the ETSI standard, I think, mentions master and slave devices as two categories of devices, and explains what they need to do for DFS. Mesh nodes, I believe, are assumed to be master nodes, but last time I checked, I think the standard didn't talk specifically about mesh nodes. And what makes the situation much more complicated is that there are so many parties involved in this problem. This is communities like Funkfeuer and the manufacturers of devices, but also the officials, like the persons doing the radio monitoring, the radio authorities of a country. Then there's legislature, and information between them doesn't really flow too well. And this is just a quick map drawn with heywhatsthat.com, which shows the reach of weather radars in and around Vienna. So the first one, let me just try and circle that. So this is Vienna, right? Approximately, it's not too exact. And the thing that's highlighted in the middle there, so this is the weather radar for the local international airport. And over in Slovakia, there's Bratislava. Right next to Bratislava, there's also a weather radar. And again, this is Vienna, something like that is Vienna. And the weather radar is over there. And we know the frequencies of these weather radars. These are in the 5 gigahertz band, and this translates to channel 124 for the Austrian weather radar and channel 120 for the Slovakian weather radar. So what happened in the situation that caused me to create this map was that Fernmeldebüro Wien, which is the national radio authority, notified Funkfeuer about a node of Funkfeuer interfering with the local weather radar. So the first thing that happened, and I'm very thankful for that, was that the node got fixed really quickly. So wow, thanks. This was really just sending an email, and it was done, yeah, with the highest speed possible. What was very nice of the radio authorities was that they also put us in contact with the radio operators at Astro Control, and they then went and gave a talk at the Funkfeuer meeting. This later on developed for them to give us contacts to EU METNET. This is the Network of European Meteorological Services. And it turns out that these guys have a map of radars across Europe with all the frequencies and positions in there. And after checking with them, they allowed me to make a new map, which is based on their data. So this is basically the story as it happened. And now I'll try to share my screen. Give me a second to find the right couple windows. So let's see. I'll share that window. Okay, and what I'm showing here is a paper on arXiv, and I can post a link later on. This is just for you to get an approximate idea of how it looks like on the weather radar when a Wi-Fi device doesn't use DFS correctly. So the green and blue blobs, these are clouds, and this is what the radar is good for. It shall find clouds over the sky, obviously, and precipitation. And sometimes there are these triangular shapes which happen because there was a Wi-Fi station transmitting on the channel that's used by the weather radar. And sometimes these interferences can get pretty bad, and then you only see these triangles and don't see anything of the clouds anymore. And this, of course, is a big problem. And this is why DFS exists, basically. So I'm switching over to another tab in my browser, which is the Opera database by EU MetNet. So this is these are the data on radars, which the nice guys allowed me to reuse. And as you can see, there's quite a lot of radars all across Europe, and they don't have data for any other countries. And if I click on something, then this opens a small window showing details about that specific radar station, including, as I said, the position of the radar station, but also the frequency that it's operating on. And I think it also has a range parameter somewhere, but I don't find it while I speak. Anyway, I think you get the basic idea. So that's the raw data that I was using for my map. And now to the thing that you saw on the second slide of my talk already. So this is a rehash of the same data, but this time grouped and colorfully grouped by the channel that these radars are operating on. And when I zoom in now, let me just go to any random position in Vienna. And here we go. So this is just a Wi-Fi station anyway. And what the map now does is that the last line down, or the last two lines actually change. So I get the marker coordinates, and I get a list of channels on which to expect weather radars in that position. Now the channel is the map is as accurate as the data that went into it. So for instance, right now we're somehow in this yellowish circle. And if you zoom out a little further, then you see that this must be a weather radar somewhere in, I don't know, perhaps Italy. I guess it is in Italy. And it's pretty unlikely that you will actually hear this weather radar in Vienna, because there's the Alps somewhere. So there are mountains, and I don't think that the weather radar is positioned so high that it can actually reach Vienna. But anyway, this is really just a matter for you to have an indication of what channels could be occupied by weather radars. And I should also say that you cannot turn off DFS just because you took a look at this map, obviously. So DFS must be on for the channels where it's required. But at least this map can give you a certain idea about the occupied channels, of the channels occupied by weather radars, and by this save you some time in your network for having it automatically switch channels. So the comment was to show the interference with the weather radar once more. So here you go. As I said, I'll paste the link in the chat. And yeah, just to explain, these green and cyan and blue blobs are actual clouds, and then there are these triangular shapes, and these are interference problems with Wi-Fi. I hope it could be seen on the YouTube stream now as well. Okay, and now what will I do next? Now I will go back to my slide deck. And this is almost the end of my presentation already. Yeah, so this is just a thank you slide, actually. Oh, thanks, Hauke, for providing the link to the paper. And I would like to say thank you for the cooperation to the Funkfeuer node owners, obviously, because as I said, they were very quick to fix the problem. I'd also like to extend my thanks to Funküberwachung at Fernmeldebüro Wien. These are the authorities, the radio authorities, and they were very nice in helping us to contact also control, which are next on the list, the operators of the weather radar. And EU MetNet received super special thanks for allowing me to use their radar database and create my own map. And I should also note that my colleagues at work, Oliver and Christian, provided lots and lots of helpful feedback for the development of the map. I'm sorry. And last but not least, even you could say the most important part of my talk is that I would like to ask you for your help. So the basic structure of the map exists, and I'll share the source code with you in a minute. And I've seen that there exists weather radar position and range data for other countries and continents, but I'm not quite sure if I'm allowed to use that data. So if you happen to live in one of the regions which are not on the map already, then I'd love to get in touch, and maybe you can help me with your local authorities to get access to the data and get the license for the data so that I include it in the map. Or, of course, you can just start your own map. This is just fine. But I think it would be interesting to have a map that covers other ranges. So, for example, I know that data for the US exists, and you can find it on the web. But I found no indication whether you are allowed to use it at all. So I chose to not use it for the time being and rather wait for maybe one of the colleagues who's in this meeting right now to help me figure out whom to contact and how to get clearance or how to get a license for reusing this data. And this is it. It's time for questions. And there's a couple of links there: Funkfeuer Wien, list of Wi-Fi channels, EU MetNet, and so on and so forth. Oh yeah, the actual radar map. I should say that it gets a GDPR warning because the web server is going to track you. So it will save your IP address. I think access, no request string, details about your browser. And I can see them later on if I go and look in a statistics window. So if you do not want me to be able to see your IP address, then please don't go to that web page, but just refer to the first page of my second page of my slide deck, because the channels with red, green, and blue colors, these are the ones that are used in Europe. In most places. There's a question from Georg K111. Is it necessary to activate DFS and automatic channel selection on mesh nodes that do not use the mentioned channels? Absolutely yes. Absolutely yes. Just looking into this map gives you an indication of the channels that you might want to avoid, just so not to run into DFS events. But still, you are absolutely required to use DFS because it's not clear whether these are all of the radars that exist. There might be military or I don't know, other radars that might show up. And yeah, it's the law. You are simply not allowed to disable DFS on channels where the law says you must use DFS. So this is really just for information and for helping you to select channels which are less likely to run into DFS events. Yeah, that's it. There's no next slide. More questions if you like.
So cool. Thanks. Anyways, from everybody, I guess. The applause is coming in. Hey, Hauke.
Yeah, I heard that not all these weather radars are really affected by Wi-Fi. Do you have there some information? So I read somewhere that only the old ones and the new ones with DSPs are not affected by this, and they're calculated automatically out.
I haven't heard about that actually. The radar operator who visited us for a talk said that they have methods to try and avoid positions of the radar dish where they know that interference may happen. But I have not heard yet about a way to remove these problems from the signal afterwards. I mean, I think the paper that where I showed this figure mentions some basic ways where you can just ignore parts of the picture that were disturbed. But I'm no radar specialist though, so I just reused the data that was available after they allowed me.
Okay.
Okay, so yeah, there's more questions. Georg asked that if you should use DFS and autoselect. That's a good question. I don't think that autoselect is required. I think you could possibly supply a list of channels that your Wi-Fi device enables after switching from one. But yeah, I just know that DFS is the requirement, but whether auto selection is a requirement, feel free to look that up in the ETSI document. I don't think it is. I'm not sure. Tango WRT says, do you have any indication that some of those radars may be not active 24/7? Yes, we have that indication, at least from the local radar. Sometimes they need to change tubes or cables or anything. Sometimes the weather is clear anyway, so they're not going to search for clouds. So it goes on to say, particularly we've been experiencing some radar events synchronized on multiple exposed nodes, so most likely not a false positive, only in certain weather conditions, such as 10 minutes before upcoming storms and up to 2 hours after. Is that common? So again, from what the colleague told us, I think that they are surveying the clouds in much greater detail as they arrive. And this might be an explanation for that. And yeah, from the operating principle, I mean, they're sending 5 gigahertz pulses up to the clouds, and the clouds are reflecting them, and they're collecting the reflections and the echoes. So it's very likely that your Wi-Fi stations will also just pick up the echoes, and if the radar transmits, but there are no clouds, there will be no echoes. So that would make sense to me. Ventlov asks, do you plan on adding nodes representing the position of the radars? I expect DFS to be related to transmission power, which means distance to the radars. That's a good suggestion. What I was thinking of was to add shapes of the expected range, transmission range of the radars. So, as I said in the example, I don't think that a radar in Italy or southern Italy will be able to reach Vienna just because of the Alps, for instance. That's sure a good addition to trying to make sure that the radar ranges are more representative of what you actually see. And I think that there were also projects to try and collect DFS events from routers, where you could register the position of your router and then install a little package that would send to a central collection server the information that a DFS event happened. But as far as I have seen, not too many people participated in that. So maybe it would be a good idea to start it up again. I don't know. Maybe next year. Let's see. Klaus adds, some years ago, I worked on a project trying to get rid of DFS. Okay. If you want to provide a short summary, please go ahead. And Zach says, we also have this problem in the US. Obviously, in some areas, NYC, it is so bad that we need to have both DFS and manually disable the use of known channels of radars because too many buildings and reflections cause buildings to fail. It's been a big issue. Okay, that's very interesting. It's probably, okay, buildings, no detection. All right, okay. So reflection causes detection to fail. That's interesting, and that's probably something very specific to a city of that size and building density. Oh, and I see that I'm going over time, and sorry to mwarning, who I think should start the next talk in like 2 minutes ago. So,
Yeah.
Okay.
Thanks a lot.
Thank you. And if you have any further questions, my email address is right at the bottom of this slide. And okay. Can I read just one more comment related to power? Be aware that radars can burn your radios if you're close enough and your antenna points to the radar direction. Yes, I can imagine that. I mean, we heard from the local radio operator that they have, I think, a 40 or 50 dB antenna. And if you have a bigger antenna on your side as well, and they're transmitting with, I think, 5 kilowatts or something like that, then this may get hot in your local device, indeed. Thanks, Hauke, for posting the link. So yeah, just be reminded that if you click that link, this will cause statistic information to be collected by the university web server. So don't click the link if you don't want these statistics to be collected.
Cool. So we're almost perfectly on time. Moritz, you there?
Yes, do you hear me?
Yes, loud and clear.
Okay, let me switch on my cam if that works. Multiple clicks. Well, I'm a bit dark, but let's see.
You should have presenting rights now.
Okay. Do you have my slides, or do you want me to upload them?
I received the last iteration that you sent by email, but
The
I
second
didn't
one.
upload them yet. Mm-hmm.
Okay. I don't know how to upload them, so I haven't tried that yet. Wait, actions, upload a presentation. That sounds good.
Okay. Here you go.
Okay, select.
Everything nice. We have 76 people watching now.
Yeah.
So
There. Okay, I need to. There was something out of the window, and then upload. Let's see, converting file.
Second.
Processing pages. Okay, it's looking good.
Yeah.
Do you see something?
Perfect.
Okay, let's start. Hello, everyone. My name is Moritz. I live currently in Berlin, and I'm with Freifunk since 2011, quite a long time by now. And I'm always interested in how to make big decentralized mesh networks. And well, this got me, of course, interested in routing algorithms and different communities. And the first step then is to look at other routing protocols and see how they're doing. And I found out, okay, you can do mesh networks with a few hundred nodes, but after that it gets quite not so pretty. And so I wrote myself some basic dummy routing protocols and wanted to test them, and of course test other routing protocols that are much better at that. And and I'm here to present my results. I mean, it's a Battlemesh. I guess it's very fitting. And first, a disclaimer. I mean, this is a Battlemesh. It's usually can be rough if you present results, and so please take the results with this with a little bit of a grain of salt. I think the results are interesting nonetheless. So let me start. So I've been at a few battle meshes before, and recently we kind of stopped doing battles and comparisons because everyone wanted to socialize, which is perfectly fine. And then Corona hit, and now we are having this virtual one. And and so my testing, I think, fits quite well.
So let me get to the first slide. So this fits quite well as a motivation for giving this talk. Because at the previous battle meshes, if we did battles there, we usually had something like 15 to 30 routers, and we usually tested throughput measurements. And of course, you couldn't do all the tests at the same time and under the same conditions. And my personal interest is mostly in scalability and stuff. So it's not like you can buy a few thousand routers or at least a few hundred and bring them to the battle mesh. That would be like a huge undertaking. Yeah, so let me invite you to some virtual battle, which has a few downsides and a few upsides. I can test scalability and stuff like that, but of course, if it comes to radio interference patterns, stuff like that, and being really too well on a Wi-Fi router, that's something I can't do, and it's pretty expensive as well. So yeah, so I think that's a good way. Okay, next slide. Okay. Yeah, my framework is called the MeshNet Lab, and it works on by utilizing Linux network namespaces. This is one of the building blocks you might know from LXC, Docker, and stuff, which are quite similar in a sense. And I've just listed a few of those things that I entered on the console to verify that it might work. So here I do just some Linux network namespace. So what it means is you make a namespace, you have a little different kinds of them under Linux, and you can start, and of course one of them is a network namespace thing, and then you can start application in it, and they will only see interfaces you put in there, and they don't have access to anything network related outside of that scope. So here I did a dummy network namespace, and there's a loopback interface inside, and it's not the one you see usually. So you can just prefix your command with IP netns exec, then the name of the namespace, and then some command, doesn't matter, like ls. Of course, it's network namespace, not file system namespace, so it works as always. And yeah, from there I got one step to another, and here see I do like a virtual pair, like really a cable which is with two ends, and yeah, and so you put some packet on one side in, and it comes out on the other side, and I also put some bridges there, and then I can move these interface ends to different namespaces and start programs like mesh routing protocols, of course, inside these namespaces. And voila, I have something like yeah, a big pile of cables and namespaces I can plug together to create myself something that will resemble a mesh network. Okay, this is a bit more technical. I mean, this is I have, for example, to have these three router nodes, for example. In this case, it's a network namespace A, B, and C, and then I create those, and I create a lot of cables and plug them together. Then I have a namespace that I call switch. That is where I hide all the ugliness, and there I have bridges which have some features disabled, so basically hubs in a way. So I have something like that is some broadcast domain in a sense. And yeah, and from there I can plug in together my mesh networking laboratory. It's written just in Python 3. It's just a bunch of scripts to create JSON files that are my network, and then I have some programs that do tests, that set up software and combine those in whole sets of tests you can look up online along with the results. And I've also like a collection of different JSON files that contain topologies like grids, lines, some random tree, and of course I just picked up some networks from Freifunk communities where I just got to the mesh viewer page, the map they have, and just downloaded the JSON file, did some small transformation, and then had something that you can plug and replicate on my computer. And this is possible when you have this is something you can do on your own if you have a Linux kernel, at least with version 4.18. Yeah. Okay. Yeah, and my tests, well, I told you I'm very interested in scalability because that's very expensive if you do it with real hardware. And also the mobility, where I just assign every node some virtual GPS coordinate and then say, okay, in the next time step, every node moves around. And from there, the new connectivity parameters are selected, and then the network, the virtual one, is changed. And yeah, and then I can do measurements like ping and throughput and yeah, different kinds of stuff. And of course, I've already mentioned some limitations. Well, it's in real time. So if I have a lot of beefy computers, it doesn't mean like this emulation is running faster. It takes quite some time. And some of these simulations actually run a whole week on a bunch of computers. Even though the CPU usage is mostly very low, but when I scale up the network and do tests with like 2,000 nodes, that's the maximum I tried, then I get the CPU at very high usage values, and that's, well, it's a dangerous thing because it really, well, you can be very sure that it will influence your results, and that's something, of course, you really want to avoid. If you have something like a event-driven system, then there's the benefit that you can just throw lots of CPU at this problem, and it will just simulate faster, and you get faster results, and the result will not be affected. But mostly in these cases, you have to modify the firmware, the software of your mesh routing protocol. And since I've tested a lot of them, that's not really feasible. Okay. Yeah, I've tested a lot of different mesh routing protocols, as you can see. I think many of you know at least a few of them. A bit standing out of this crowd is Yggdrasil, the first one, because it's not really used for mesh routing in like community networks with Wi-Fi routers, mostly over the internet. But it's still, I think, a good idea just to throw it in. CGDNS is a bit older, so is OLIS R1, or OLIS RD, I should say, but I said 1 because it's easier to distinguish, as in 1, 2, well. And recently I added BMX7, so thanks to those people who helped me with that, because I had some problems configuring it. I also have some help with OSPF, but I didn't make it to get to work in time, so I don't have any results on that. So let's dive into actual results. I hope that's the next slide. Yeah, so the first thing I do, I have something like a benchmark test and see how many mesh routing protocols I can run until everything breaks down. And in this, I hope you can see that, or maybe I can. Yeah, I think so.
You can zoom.
Oh, I can zoom. I don't. Ah, yes, there's some zooming. Okay, but I think that should work already. So I have a laptop and I have access to a server. And as you can see, I tested just 3 in this case because it's just 3 different routing protocols to see how much can I simulate until it really affects my results. And I see with my crappy laptop, I get with Batman around 120 maybe before the number of packets I send get lost. So this is some grid of nodes with let's say 50 is then 7 by 7 around that nodes. So it's really like a checkboard. And then I'll start all these mesh routing protocols and see how many of my pings, I sent a lot of pings there, how many of them get lost. And you see here, it's mostly 100%, even with Babel. I don't know why it's not quite 100%. There's a lot of open questions here. And so I said, okay, with like when I only limit myself with 100 nodes on my laptop, for example, I should be on the safe side. And with the server, yeah, I guess 200 at least should be also safe. So that's something I did first. Okay. So next slide. So one of the first really useful tests I did was like I tested the convergence, which means I have a line of different, well, how many? I did 50 nodes in a line, which is really an atypical setup, but I thought it was interesting nonetheless. And I started all the one routing protocol. I waited some amount of seconds, let's say 10 seconds, and then I sent about in 2 seconds or 200 random pings to random node pairs, and saw how many of those packages were actually delivered. And as we can see for like Yggdrasil, it is quite fast. So after 10 seconds, when I measure, like 100% of all my pings arrive. And I mean, this is practicality-wise not very useful, because usually a node, of course, runs more than like 30 seconds. So startup time is not really that important, but I think it was fun. And you can see that, for example, Batman, it takes about 30 seconds until the nodes arrive, the pings arrive. But you also see for Batman, for example, that not all of the pings arrive, even after like a minute. And I have an explanation for that. And that's because Batman has like a maximum hop count, basically. Well, it's restricted by the metric, how many hops you can send a packet, even if you have good connections. And so don't say here that Batman is bad. It's just a really atypical test case. But you see at least the timing parameters that these mesh routing protocols work with by default. Okay, next slide. So I did the same on a grid, and now we have more clearer results, and we see that, yeah, for Batman at 30% it goes up to 100. And so that's perfect, and everyone else does very well, except CGDNS, which is a bit, well, drunk, I don't know. I saw this like spike in all the tests I did. It was reproducible. I don't know why it is. At 30 seconds, it does something. And that has a negative impact on routing. No idea why. Okay, and then the next case I did for this convergence test is on a random tree. I will later show you how it looks like. It's basically a tree structure that is a bit random, but still a tree. So you don't have any routing loops and stuff like that. And so usually I would expect to, for all routing protocols, to do quite well here. And actually they do. And well, and CGDNS is already, yeah, it's not doing that well, but it does routing. Let's say it that way. Okay, now to some more interesting tests. Oh, here I have a small summary of my findings. Oh, I said here, Batman Advanced is at under 100% with this line test because the maximum hop count is limited by the metric, and this results in a 32 hop maximum apparently. And yeah, it's not really that interesting. So let's go to the next slide. Okay, now I see there's should be an animation, but it's not there because it has been converted apparently. Well, nonetheless, this is an interesting thing. This is my mobility test. And what you see here on the right is the node setup I have. So every node in the JSON file has some GPS coordinates, random. It's a simulated 1 by 1 kilometer square. There are some nodes, and when they are at a specific distance, they are connected. And in 30-second steps, they move in a random direction by 10 meters. And of course, some connections get lost and some got established. And over time, I tracked how many of those pings I sent. How many did I send? Okay, it wasn't written there. Okay, but I sent enough to get an accurate result. And mostly it's 100%, for example, with OLS R2 and all the others mostly. And there are only 3 protocols which struggle when the topology changes. So these are, it's Yggdrasil, it's CGDNS, and BMX7 also has some problems here. And I've also tracked, which is interesting, this is not different results, this is just a different way to display it. So we see here for Babel, 100% of all packets at all times arrived, same for Batman, same for BMX, and the others except BMX7 and CGDNS and Yggdrasil, which you see here in the graph. Okay, now let's put in some more mobility. Next slide. Now we make bigger steps of 60 meters. And now you see that it's getting a bit harder for the routing protocols to adapt. Of course, the results are always dependent on the settings. I usually always use the default setting, so it's mostly easier to just say, it's often the case when you say the routing protocol, yeah, send your broadcast instead of every 30 seconds, like every second, then of course you will have a drastically different result. So take this with the same, with a piece of salt, or grain of salt it is called, and but you see basically the same result. And then I did another test where I no, that's a summary. Okay, yeah, okay, that's something I said. They're not doing that well with mobility, at least with the default settings. I mean, Yggdrasil and CGDNS are mostly for internet-based networks, so that they are not really that adapted to mobility is not a surprise here. And this is a different test where I also tracked down the amount of traffic. And I think you can't really read what I've written above. I mean, I can just tell what you see here. So this is all the same test. The graphs are, well, okay, data, and the bars down there is just the summarization of the graph on top. And what we have here is packet arrival from 0 to 100% of all the nodes. This is like a different, a similar setting as before, but different initial node placement. But of course, for every node, it's the same. So I set the random generator for that to the same starting value. So I will have the same ground for the mesh running protocols to go through the same test. And what we see here, for example, down here is that Babel doesn't do very well here. I don't know why. There are not a lot of packets that come here. I mean, I have to say this is quite a lot of mobility here. Oh yeah, I see here move in random directions 50 to 400 meter in 50 meter increments. Okay. Yeah. Anyway, we see here that Batman Advanced is doing quite well, but BMX and BMX7 are doing quite well. This is a lot of mobility here in this test, and we see that traffic-wise, so this graph is traffic, and we see here this is a transmission traffic in kilobytes per second, so this is about 10. Here is about 5 kilobytes per second, and we see that CGDNS and Yggdrasil do a lot of traffic, but the other ones are quite low. So how many nodes are here in this network? 50. So with 50 nodes, we have with quite a lot of mobility and some pinging. we have about 2 kilobytes or less for most mesh routing protocols. Okay. So next one. Okay, these are results. Okay, we have a high mobility scenario here. I don't have this a nice animation, but apparently it doesn't work here. So, well, can't be helped. We see that BMX is quite doing well when it comes to low traffic, but of course you have always to say, yeah, but what if we have actual traffic? So that might be a different case. I only measure like really with low traffic, just pings, see how if there's connectivity. I don't do throughput. That may be a completely different test. But yeah, I don't have that much time for now, but it's interesting. Okay, and what else have we seen? Yeah. Yeah, I guess you can just read what I've written here. Afterwards, let's go to the next result. Yeah, and it's the results are really like a bit controversial in a few things. Of course, you can't really. Well, there's always the question: are these results like related to reality? I mean, how much? I mean, I really would like to say yes, they're really related to reality. As much as the overhead goes, it's something I see in reality, but some behaviors I can't really understand. Maybe someone that knows the protocols much better, or well, specific protocols can tell me why I see those results. But it's interesting, nonetheless. And now I think these are for me the most interesting results, which is scalability. So let's have a look here. And of course, I started with this pathological case where I have like a line of routers, and I took it to extreme and said, yeah, up to 1,000 routers in a line. It's insane. And then you can see, of course, the number of nodes up to 1,000. Then the traffic. I mean, here we have like 6 kilobytes per second. And yeah, what do we see here? I mean, okay, on the right side, this is important for this slide. We have also the amount of packets that arrive. I mean, here 100%, 0%, and these are the dotted lines. And what we see here, I think this should be the first one we have to look at, is that all these dotted lines of all the routing protocols are going down. And they're here going to, well, very low percentages. So say any of those pings I send have a really low probability to arrive if the amount of routers in one line increases to really big sizes. And this is not something you would see on the internet or in real world in any case. What we see here, for example, is Batman is like going up, and then at some point it flattens. So this is the amount of traffic. And yeah, and if you keep in mind that there's like a maximum hop count, then this result makes absolute sense, that it's like flattening here. Then we see the other routing protocols go a bit linear, and some, well, OLSR1 is flattening at, well, I don't know how much it is. It's not much. But when we think about how many packets we lose here, then the result is, yeah, we can scrap this data, because if no really good routing is happening at all, then we won't bother to look at any other data. So, but I thought this is interesting results to put in here. And yeah, that's the summary. Yeah, packet loss is too high very quickly, and that means the traffic data is becoming meaningless. Here's a small view how this topology looks like with nearly 50 nodes. Oh no, those are 50. And now imagine if we have 1,000, which is really ridiculous. Then yeah, you can expect some packet loss if your routing protocol is meant to work on Wi-Fi links. If these would be Wi-Fi links, then we quickly would have no packets coming through at all. But or maybe I've missed to tell you that all these links I tested with are usually like 100 Mbit simulated with about, I think, 1 or 5 millisecond delay. I think 1 millisecond in this case. And yeah, just so you know, keep it in your mind. And now when it comes to grid, we get some really crazy results. So imagine like a checkerboard with up to 2,000 nodes total. And what I've also always seen in these graphs is for Batman and for OLS R2 to have like this mountain. And they are up to like 600, 700 nodes. Then the amount of traffic drops. And of course, I mean, here so does the amount of packets that actually arrive. I mean, when I send pings. So this is, I think, the result for Batman, at least, because it's a kernel module, and I've had a lot of problem scaling that up, because in the kernel, you have an interrupt handler that is single-threaded, and Batman is using a single-threaded one. So it's really hard to scale. What I did is I started everything like running in the same kernel context, but different network namespaces, which is really good if you have like user space programs, which are all of those I have tested except Batman. But for Batman, it's a bit of a problem for me. So I had to do some tricks where I distributed the simulation over up to 20 nodes, of which 1 core each, which is a bit crazy. But that's the only thing how I could get Batman to scale better. But even then, after some sizes, I mean, if I distribute like 600 nodes on 20 nodes, then every node will have like 30 Batman instances. And this was a slow core, I think. Then there we will hit the interrupt handler limit, and then the packets won't get delivered. They will be dropped quite sharply here. You can see this blue dots going down. And for OLS R2, I don't know what's happening here. That would be interesting. I already know from all my results that Yggdrasil is really erratic and not very good here in these scenarios. I mean, Yggdrasil, for example, is a tree-based mesh routing protocol, but we have seen before when it comes to scalability, to mobility, then it's quite erratic with traffic, and the developers are already working on that. But for this scalability thing, I don't really know what's happening here. This is with most of the data. It's something I have to figure out. But we also have, of course, to look at how many packets arrive, and it's quite low all the time. So I would basically scrap that data and need to think about what is happening here. I mean, does it even reach? Oh, sorry, that's the traffic here. Not. I was thinking in percent. But of course, on this side, it's also very low. So, well, I don't know what's happening. That's simple to say here. CGDNS, yeah, it's the percentage of packets that arrive is going down also quite a lot. But so the only thing we can really look at here is all the data where the corresponding dots are really on the top. Let's see here, Babel, for example. So the traffic grows linear. I mean, this goes from most routing protocols I've observed. It's linear. For some, when it's quite high already, then it looks like constant. But I don't think it's constant. It just either way, it's not delivering packets very well, which we see here, for example, the brown ones for CGDNS, which goes down. So not very good. And OLS R1 is doing quite good here, I think. And so does BMX6. And it also has here some weird behavior at around 1,300 nodes. I don't know what's happening here as well. Yeah, but let's go to another slide with this random tree. Oh no, that's the result. I did some calculations how much per 100 nodes the traffic grows, but actually I think this data is not really for this slide because I updated the data and I thought I had deleted these. But okay, but you see how the grid looks like when it's just about 50 nodes. But let's go for the random tree. And yeah, we also have this like nice going up of the traffic with Batman. I don't know why. It's here it goes up with, for 1,000 nodes, we reach 50 kilobytes per node. So that is sent per each node on a link, which is quite a lot. I don't know why it is that much. But maybe people who have actual Batman networks of that size, or maybe at 400 nodes, can say, yeah, it's about this range, like 20 kilobytes with nearly 400 nodes. And okay, we basically know why this is going down. We need more processing power here. But yeah, with running in the kernel, it's a bit hard to scale. And yes, for the other mesh routing protocols, they're doing quite nice, except where is the orange one? OS R1 is not doing very well. I mean, the percentage of package where we come to over 1,000 nodes, it goes down very much. So it's here's 50%. So at 600 nodes, OS R1 is only like 50% of all packets arrive. And we only send pings, and yeah, CGDNS is also not doing well, but everything else is doing fine. I mean, 100% of all packets arrived. And so we can look at this graph and say, yeah, these are more or less authentic. And yeah, it's nice to see that for these for 2,000 nodes, we only have like yeah, less than 5 kilobytes per second per each node that is sent, and that's quite good, I would say. Okay, and here's how this random tree looks like. So we have a center node and then a tree and no loop, which is also a bit atypical. And usually what we want to do when we have mesh routing networks is that that we need to cope with loops, but in this case there are no loops, so that's interesting. Yeah, and we've seen that traffic increase for each link is growing up linear, and yeah, and for some routing protocols or for Batman a specific from some specific size of the network, the packet loss is very high. Maybe it's because this is of the CPU, who knows? And basically, these are the results. Oh, wait, there's one more thing. I did something where I already told you that I've downloaded the data from Freifunk networks to actually work with real topologies. But of course, when it comes to packet loss and bandwidth and such, that's not something that I've replicated here. So I can do that, but that was just, there was no time and motivation to do it, maybe another time. And I also did some small networks. I have data for, like, I think Freifunk Munich has 1,800 nodes, but this was just, I didn't have time, and my test setup, wasn't very well behaving, so yeah. But it's interesting to look at least at these results. We have around 200, 300 nodes. And I've run a few mesh routing protocols on these topologies. And what do we see here? Packet arrival. I don't know. I mean, for Ulm, for example, we have like 100% of the pings arrive. But for the other ones, it's quite bad, and I have no idea why. And as for traffic, Batman is producing a lot of traffic, which is also interesting. But I think this is like a test that isn't really refined, so I really have to look up if I did something wrong. So that's a to-do, but still here's some slide related to that, and I think that should be all. So yeah, so since this is a very controversial topic, I guess we should start with a discussion. Don't kill the messenger, I would say. The sources so everybody can like try to reproduce the results. The software is on, and all the tests are automated on GitHub on my project. There's a folder called tests, and there are different tests in different test folders, and there's a script called run.py. And when we run it with sudo, it will just automatically run this test, and the end you will call the plot script, and then you will have the exact same graphs as I do, maybe of course with a bit different results, because you need to make sure that your PC is beefy enough to not to affect the results. And with such, I say thank you and would like to answer your questions. I don't know how this works. Am I supposed to read the questions from the chat and then answer them?
As you like, yes.
Yes, okay, so let's do that. Okay, Zero, very cool. Thanks. Yeah, thank you very much. So all these nodes, okay, Reverend Low wrote, so all these nodes share the same computing power. As you said, emulation, not simulation. Do you think it's a problem for some routing protocols? Yes, Batman was a problem here because it's running in the kernel and it's single-threaded there. So if I have a 64-core monster, then Batman won't do good there. If I have 64 hardware routers, then Batman will be much better, very, very much so. And I must be very careful with these, with my testing, because the effect of the CPU and the throughput on the test results is really a big problem, and I have to first test if the impact is really meaningful. It's always good, of course, to throw a lot of computing power at the problem to make sure that the results won't be dictated by the CPU, or for example, the I/O of your computer. Okay, next questions. Comment. You might want to look at Mac 802.11, which AWSim, which allows you to emulate Wi-Fi cards in the Linux kernel. Oh yes, that's interesting. I found this project this week, and I haven't really looked into it very much because there was no time, but I really would like that. I mean, what I found was a project that uses this already. Maybe I can put the links in the final slides as well. Okay, so yeah, I know about it, but I didn't have time to look into it. Okay, next point, for mobility, what changes? Just the connectivity. Yes, only the connectivity. I can do that. I like increase or the latency or the jitter or other properties of the link. That's something I can do, but I wanted to keep it simple for now, and just said, okay, before 50 meter, for example, distance in the virtual space, then the connection is good, and after 50 meter distance, it's not existent. So that's of course a drawback. I can rectify that. It's something my code supports, but I haven't bothered yet to implement that, to make it to use it in this test. Okay. Oh yeah, okay. How are the nodes starting? In simulation, usually I start them at random times because starting them all at t equals 1, t equals 0 means synchronization and poor performances. Yes, I'm guilty of that. I start them. I start them mostly at the same time, but there's always a delay. When I do the distributed start, then of course they are started at the same time, but on different computers. So that shouldn't be a problem, probably. But even then, I start multiple instances on a computer, and then it takes some time, and when one instance is started or at least detached from the terminal, I start the next one. So of course I can maybe add some jitter there and see if that affects the results. Okay. Next, were you testing Batman 4 or Batman 5? I think it's Batman 5. It is by default enabled by the Batman version I've tested. More questions. Let's see. I'm looking for the question mark. Yeah, there's a question mark. I've already used core emu emain to perform the same kind of test, but not with so many nodes. Is there a plan to integrate emain to the framework? Yeah, I think I have a link to that project already on my project page, because I did, of course, a bit research if there are things, projects that already did that, what I do. And of course, I mean, I found this project, but I didn't know how to, well, do it what I want. And also I don't have much good hardware. So, and I wanted to test scalability. So my first thought was, okay, I have to throw away a lot of layers of emulation, for example, or simulation. I have to throw container ideas out of the window, because it's just not something I can test with with the performance I have available at my fingertips. So yeah, for me it's just a nice framework to test my own routing protocols and to compare them. And since we have Corona and a need for battle, as I said, okay, let's test some mesh routing protocols and present the results. Yeah, and I really would like to have a mesh routing protocol that scales beyond like 2,000 nodes. But this is like a different class of mesh routing, I think. Okay, next question here. Can you comment more on, wait, someone said something and then everything moved up. What do you think about running each node in QEMU KVM, considering OpenWrt x8664? Yeah, the thing with QEMU, even with QVM, I don't know. I already said that I really are desperate for a lot of efficiency, and I'm willing to drop out a lot of real-world behavior just to get to a lot of nodes. So I don't think that will do with QEMU and KVM. But please prove me wrong or convince me otherwise, because if we can get like OpenWrt in a container running at really low overhead on my shitty computers, then yeah, let's do that. Okay, next thing. When can we read the paper? There is no paper. At least I don't think the results are of such good quality that I would consider them paper-worthy. Maybe at some point, then when I feel confident that I have results that reflect reality in a manner that we can extract progress from it, then of course, yeah, we can do a paper. Okay, and Simon said Batman Advanced default is Batman 4. Yes, Simon. Yeah, if you are right, probably if it's Batman Advanced 2021, when the default is really the Batman 4 algorithm, then it's Batman 4. Okay. And Reventlov, okay, so he said 180 gigabytes of RAM for 3,000 nodes seems okayish. Yeah, but I don't have that much RAM. I would like to. Yeah, and Electra is asking, what was the definition of packet loss per link? That was just, I sent over most links, between different random pairs of nodes, a ping. And like, let's say I sent 100 pings over random pairs of nodes, and 80% of them arrive. Then I say I have a packet loss of of 20%. So it's not like the packet loss of a single link, but aggregated over a pass. Oh, yeah, that's a really good point. What happened with the results of the BMX7 routing? Yeah, you saw maybe on the scalability slide, the BMX7 graph was like cut off at some early point. That's the thing, it's still running. So 2 hours ago, I said, okay, let's grab the result as they are written to the file and put them into the graph. So that's why. And yeah, but for the other ones, it didn't take that much time. So you see the results there. And yeah, I think we've got to the list of all the questions. And if you want to talk about this topic, I'm really happy to do that, because usually when I talk about these topics, mesh routing protocols to people, they start to get up and leave, which is understandable, depending on the people. Yeah, so please get in contact with me if you have suggestions and yeah, how to make it better, or if you have like beefer hardware I can use to make better results and scale to bigger size networks. And with that, I would say thank you very much for the opportunity, and see you maybe in real life at some time. Oh, there's suggestions to make a small room and for the discussion. So yeah, of course we can do that. Please don't blame me that your favorite routing protocol doesn't do very well with this test, but well, it's just something that came out of the machine, and of course it's might not really be real world, but it's interesting nonetheless. So don't kill the messenger, of course. Thank you very much.
Cool. Thanks, Moritz. That was impressive stuff.
Yeah, it was quite right. I started this project, I don't know, last year, and thought, okay, it would be interesting to test all the routing protocols out there in a reproducible manner, and also throw in my own routing protocol, which doesn't really exist yet because it's so shitty. Yeah, and I will continue to work on it, and hopefully can provide next talk with better results and more accuracy, like increasing or decreasing packet loss on the distance, and some jitter and stuff.
Absolutely. See you next time in real life, I hope.
Maybe. Let's see how it goes.
Cool. We're perfectly on time. We have five minutes until the next slot starts. So maybe we take that time to have a little break here.
Good.
Maybe just a reminder, there is a small room. I'll just post the link again in the chat. And if you want to meet over there, feel free to, but don't forget to come back in time for the next talk, which will start in about 5 minutes time.
By Dominick. Yeah, Dominick. Enhancing OpenWrt security. Cool. There he is. I'll make you a presenter. So, shall we start again?
Shall we just remind everyone else in the small room to walk over and join this talk again?
Knock on the wall.
We'll do. 1 second.
Am I audible?
Loud and clear. Perfect.
Thanks.
You want to share some video?
No.
Okay, fair enough.
Technical issues. WLAN, etc.
So everything looks nice from here. The stream is working.
Can I go?
Yeah, I think we're good to go.
Thanks. So if you have any questions, please feel free to interrupt. I would like this to be interactive rather than having a lot of questions at the end. Welcome to my presentation of an effort made to modernize access control on OpenWrt. My name is Dominick. Oh, can I have presenter? Because I can't manage my slides, seemingly.
I'm searching for your username. Where is it?
Right. Yeah,
Done
I
already.
have it.
Thanks, Paul.
All right, so this is the agenda for my presentation. I will start this presentation with a brief overview of traditional discretionary access control, abbreviated DAC, DAC. The mandatory access control modernization in general, abbreviated mandatory MAC, mandatory access control, and security enhanced Linux in particular, SE Linux. Once we have some of the prerequisites out of the way, I will address some of the benefits of modernizing traditional discretionary access control with flexible SE Linux mandatory access control on Linux systems for embedded devices in general and OpenWrt in particular. I will briefly underscore a few applicable constraints common to systems for embedded devices in general and OpenWrt in particular. The main purpose of this presentation is to clarify our main goals to leveraging SE Linux in OpenWrt and to identify the challenges and opportunities we are presented with in this endeavor. The remaining time is used to speak about the current state of our work and a look into the future and any questions, etc. All right, next slide. So I think it's safe to say that we are all aware of traditional discretionary access control to one degree or another. Some or most of us painfully maybe. Access control seems to be something we are put up with, at least until we have a genuine requirement for it. I suppose in part this explains why most of us seem to be content with traditional discretionary access control. But there are two unforeseen fundamental inadequacies in the design of traditional discretionary access control that lead to excessive permissions and privilege escalation. Discretionary access control is identity-based access control. Users, groups, and others are associated with entities. The issue with that is that there are usually more entities than there are identities. This leads to coarse-grained partitioning of entities, and that limits our ability to control access. It was said that in Linux, everything is a file. There are 7 types of files, namely block files, character files, plain files, directory files, link files, pipe files, and sock files. But in reality, there are many more entities in modern Linux systems than just those 7 file types. The traditional DAC, discretionary access control, does not cover them at all. Traditional discretionary access control allows us to control operations such as read, write, execute, SUID. But in reality, there are many more operations and interactions that most of us are not aware of and that we have no control over. One of my favorite examples of this is device-specific input-output controls, IOCTL. Traditional identity-based discretionary access control is coarse, and this leads to excessive permissions. Still following? The second fundamental inadequacy of traditional discretionary access control is its discretionary aspect. Users are tasked with access control for the entities that they own, and access control is decentralized. Yeah, if you have any questions, you can just interrupt. You know, and yeah, I prefer audio feedback because my eyesight is really bad and I can hardly read chat. To be honest. Anyways, traditional discretionary access control leads to privilege escalation. But so those two aspects are pretty important to remember, that discretionary access control is decentralized and it's identity based. Those are fundamental inadequacies. Right. So mandatory access control complements discretionary access control and is an optional enhancement. So it sits on top of it. MAC is appended to discretionary access control. MAC meaning mandatory access control. And mandatory access control can actually be used to constrain discretionary access control. So it sits below it, and you can use that to constrain discretionary access control if you want to. Mandatory access control addresses the two aforementioned design inadequacies in discretionary access control because it allows for mandatory access control, centralized access control. Wow, that was a big mistake. And entities are not partitioned using or based on identities. So it's not an identity-based access control framework. It's an entity-based access control framework. Every entity is its own entity. As a Linux supports, right, that was wrong. Let's go to the next slide. Flexible security enhanced Linux is one of the available Mac frameworks in Linux. There are quite a few more: AppArmor, SMAC, and a few others. As a Linux is defined by its flexibility and its ability to be customized. So that's what basically separates as a Linux from the other mandatory access control frameworks. As a Linux object manager covers the widest variety of entities and permissions. We call them access vectors. So the way basically to access entities in your system. Security identifiers can be declared and associated with entities and with inode where applicable, rather than path. AppArmor, the other mandatory or another mandatory access control framework, uses associates security identifiers with paths rather than inodes. So questions? Wow, that's impressive for this topic. As a Linux supports security models that address various access control challenges, such as integrity, separation, confidentiality, but also a identity-based access control security model that is used as glue to attach to the identity-based discretionary access control, because after all, it appends its mandatory access control, and as Linux is appended to this discretionary access control. So there needs to be some connection. And the SLinux identity-based access control security model is used to act as the glue between SLinux and discretionary access control. And a role-based access control security model can be used to associate permissions with SLinux role identifiers that can then be associated with SLinux identities that can then in turn be associated with discretionary access control identities. So SE-Linux identifiers are associated with Linux identifiers or identities rather, and rules are associated with roles that are associated with SE-Linux identities. And that's quite complex with a lot of associations going on. It's all about associations. OpenWrt can actually benefit from leveraging flexible SE-Linux mandatory access control because it gives us greater control over the system and it allows us to override traditional discretionary access control where needed. And that helps contain damage caused by or caused due to excessive permissions and privilege escalation, since OpenWrt is essentially, not quite, but essentially a single user system. We can and we should still leverage the identity-based aspect of discretionary access control. That's still there, and yeah, we should just use that wherever it's feasible, but that still doesn't address the decentralized aspect of discretionary access control. That remains, no matter whether you associate individual Linux identities with your processes. They still have access to govern, access to entities associated with that same identity. Oh, sorry, I basically I forgot about the slides. So yeah, this was basically all. Oh, actually, no, that's not. So continuity of system operations and hardening are important for systems for embedded devices in general, and for OpenWrt in particular. Our wireless routers are often the first line of defense of our networks and are vulnerable because they are often a single point of failure because of that. These systems have to operate continuously because they provide essential connectivity. If my router goes down, then yeah, pretty much all hell breaks loose in this household. By offering the option to leverage SE-Linux, OpenWrt becomes a viable option for parties with Mac requirements. So if you don't provide the option to enable mandatory access control, then you miss out on a particular audience that has a requirement for mandatory access control. My phone has more memory and has more storage than my wireless router, and your phone probably as well. As Linux requires both memory as well as storage to one extent or another. Systems for embedded devices in general and OpenWrt in particular often boot from a read-only squash FS, and yeah, this aspect affects SE-Linux as well. So those are two constraints to keep in mind. Options to enable SE-Linux support and support for its dependencies in Linux have been added to the OpenWrt build system. The SE-Linux user space utilities and libraries, along with SE-Linux enabled versions of procd and busybox, have been packaged and published to the applicable streams. And SE-Linux labeling requirements have also been addressed in the build system. So the framework is pretty much in place currently. Yours truly has contributed an early version of an SE-Linux security policy that is tailored to basic OpenWrt systems and operations. Now, maintaining SE-Linux security policy is always a process as software and hardware evolves. And aside from that, router model properties can differ and affect the policy. So yeah, it's never done. There's always going to be work. The aforementioned device constraint challenges are fairly constant and made a compelling case to focus on providing a SE-Linux security policy that is immutable at runtime. So you can also have SE-Linux policy be mutable at runtime, but that presents us with a bunch of extra challenges, such as, basically we have to deal with the constraints, storage, memory, mutable policy that is mutable at runtime means you need to compile policy at runtime, which takes memory, at least to some extent or another. And well, if you basically have a mutable policy at runtime, that means that you have both the sources for the policy available on the device, as well as the binary policy that is actually loaded into the system. As a Linux security policy that is immutable at runtime is relatively small compared to the alternative mutable at runtime policy. But the policy also has to be more robust because you can't change it easily. Policy is generally loaded from a read-only squashfs, and any changes to the security policy requires flashing the device for this reason alone. And on top of that, compiling as a Linux security policy at runtime would potentially also require more memory than some devices have. So that's really just not an option. I wish I could read the chat. But anyways.
This was just a discussion about the microphone being turned on when it shouldn't. But you're fine. Go ahead.
Yeah, am I audible? Hopefully.
Yes.
Yeah, all right. As a Linux security policy.
It would be kind of great if you would manage to have your microphone be like constantly on, because it's like switching off every time you're making a short break, and then I kind of miss the first words of the first letters of the first word you're gonna say. I don't know. Maybe it's the sensitivity of the threshold is like too high, and could be more sensitive.
It probably could be, and I was here to do the technical test yesterday, but it's probably a little bit short notice for me to fiddle around with the ALSA mixer and all that stuff. So I'll try to repeat once I start some sentence or whatever. Hopefully, we can make do. Yeah, right. As a Linux security policy designed for OpenWrt leverages a targeted policy model, meaning that you're targeting a specific portion of the system only. The goal is to start with moderate expectations and then to explore possibilities. The focus is at least initially on integrity. Even though as a Linux supports multiple security models for all kinds of security challenges, we're basically dealing with the fact that we want to be able to constrain discretionary access control, because these two inadequacies that I discussed are just really a thing in a single user system such as OpenWrt, because if one process has a flaw or is compromised in any way, then it can affect the whole system, and it can basically hamper the operations of the system, and that basically causes issues because, well, it's a single point of failure, and if your system is basically inoperable, then no connectivity and so forth and so on. So integrity is the most important aspect, and we want to keep it simple, and we want to have moderate goals to begin with. So the least intrusive option is to address integrity that way. So the plan is to pick the low-hanging fruit first, and to target processes with well-defined functionality. So well-defined functionality means actually easy to contain functionality. It's synonymous, I suppose. There are also some areas of interest that are not so well-defined, but compelling for other reasons to target, such as reducing attack surface, but also addressing dependencies of processes that do have actually well-defined behavior. So even though a process or a command might not have well-defined behavior, for example, an interpreter, interpreter is not a good example, but an interpreter-like command, we still might need to target it, because it is actually a dependency of a service, a long-running service that makes sense to confine, that actually is well-defined. So yeah, I try to limit myself to well-defined commands, but yeah, sometimes I have to basically move towards commands that are not so well-defined because, well, there are dependency and so forth. So Lucy is an example of functionality that is not necessarily well-defined and thus hard to confine. But targeting Lucy and its dependencies helps reduce the attack surface, because Lucy is actually a bunch of components, UHTTPD, or you might use Nginx or Apache or whatever as a reverse proxy. But then you also have RPCD, and you have CGI IO, and you have Lucy CGI, and then you have Lucy itself. And these are all basically components that run privileged. Some of them run long running, and some of them actually run as root. Well, actually, probably most of them run as root. So yeah, it just, even though Lucy is hard to confine because of its not so well-defined functionality, we still want to basically deal with that because that's just basically a huge attack surface. Now, hotlucht is another example of a process that can be hard to target, but it has to be addressed because it is a dependency of the well-defined netfd. So netfd runs hotlucht. Now, hotlucht is, you can actually drop in scriptlets to etc hotlucht and you can actually make it run whatever you like, I suppose, on hotlucht events. So yeah, not so well defined because you never know what people will drop in there, and so what hotlucht ends up running. So yeah, but yeah, we still have to address that because, well, if we want to target netfd, then we also have to target its dependencies, and so yeah, we end up dealing with hotlucht as well. But yeah, so that can prove basically problematic in the future because, well, yeah, there might be complaints about, hey, my hotlucht drop-in script doesn't work. Yeah, and that's because, well, yeah, who knows what people do. So another goal is to mitigate the negative effects of immutable as Linux policy as much as possible. Because, well, immutable policy is nice in a sense because it's small, but yeah, it's not flexible. You can't edit it at runtime. So once you flash the device and the policy is enforced, there's really not much you can do. We wanted to basically, or I wanted to basically have a way to at least get around some of the limitations presented to us by immutable SLinux security policy. So the runcon command, provided with the SLinux user space, utilities, and libraries, is used to override, or can be used to override, automatic transitions. So think about transitions in SLinux is like thinking about SUID in traditional Linux. And actually, there's a lot of resemblance between SUID, ZUID type stuff, and SLinux transitions. So transitions means transition from one identifier to another, and identifiers have permissions associated with them. So essentially transitioning from one set of permissions to another. So this command, this runcon command, can essentially be used to run commands that are otherwise targeted unconfined. And this helps, and vice versa. So you can also use it to run commands that are unknown in a confined domain, or with a set of permissions, restricted permissions, so to speak. For example, runcon -t sys period subject --iw, that would actually run the iw command unconfined, meaning no restrictions, because iw is actually targeted by default because it's a dependency of some well-defined component that is probably long running. It's probably netfd or maybe something else, but there's a chain of dependencies that caused iw to be targeted, But yeah, let's say you have some undefined functionality that hasn't been tested and, well, it doesn't work. Then you can use the runcon command to actually run it unconfined so that it actually works. So that gives you a quick fix until the policy is fixed upstream, and you can refresh the device with an updated policy. That'll actually allow you to get around that issue. The runcon -t sandbox period subject dash bmon does it the other way around. So bmon is by default not targeted, and so it runs unconfined. But let's say in my scenario, I don't have any unprivileged login users on my router. So if I log in, I'm root, and if I then run bmon, then bmon ends up running with excessive permissions, and it can damage my session. And actually, because my session is a root session, it can damage the whole system. So a quick way to work around that is to run bmon in a sandbox domain. A domain is actually basically a type, an identifier with associated permissions with them. So, basically that allows us to go either way. So optional generic sandbox subject and sandbox net subject domains were added that can be used with the runcon command to run commands that are not targeted by default in a generic as Linux container that restricts write, capability, and optionally network access. So there's actually two sandbox domains, one generic sandbox period subject domain, as well as a sandbox period net subject domain, and they both basically shave off permissions to capabilities, which is a huge win because capabilities are a thing, but it also shaves off write access to most of the system. You'll still be able to write to temp as well as your home directory, and you'll also be able to write to inherited device nodes, so device nodes that were already opened, but you got the file descriptor passed to you, and then you'll be able to write them, but you won't be able to write device nodes that have to be opened first before you can actually read or write. Or actually read is allowed, but write is not allowed. And optionally network access. So the sandbox period net subject basically allows network access, whereas the sandbox domain doesn't allow network access. So these commands, this runcon command, you can basically create an alias in your shell init file, and you can actually use that in scripts as well, or you can even use them in init scripts or whatever. So if you use that intelligently, then you can improve the system security even more, although there are limits, obviously. Right. So using as a Linux policy that is immutable at runtime means that we do not have to worry about API stability. And yeah, that's a big win, because if you have mutable policy that is mutable at runtime, then you have to deal with API stability. And so, yeah, if you change some interface or some macro or some identifier name, then you have to ensure that there's an alias, or that it basically points to a new version of a macro or whatever, and you have to inform the end user, hey, this one is deprecated, use the other one. And we don't have that issue because it's all basically, it's not mutable at runtime. So when you flash the device, the whole policy gets replaced. And that's easy to maintain. We are generally not limited to by compatibility at all, with one notable exception, which I will touch on in the next slide. And we can leverage modern features that would otherwise break compatibility. So that's an advantage of implementing as a Linux in OpenWrt, is that, well, we don't have to deal with all the historical issues and all the the things that evolved in history. We can just basically start at this point in time and leverage all the latest greatest, which is nice, but there's an exception. I wonder whether. Nope. So there's also challenges. So SE-Linux has a less than optimal reputation, along with the fact that to most of us, security in general and integrity in particular are afterthoughts. And that poses a challenge to adoption because people are intimidated. They had some experience on another platform and they take that with them, and now they have an opinion, and it's hard to get rid of that. People tend to judge SE-Linux by the security policy it enforces. That's also an issue. SE-Linux is just a robot in the kernel. It'll do whatever, or it will enforce access control, whatever access control you tell it to enforce. So if you tell it to enforce bad access control that creates issues, then SE-Linux is the one that takes the blame. But SE-Linux just does what it's told. So SE-Linux is judged by the policy it enforces. So if there's a platform where SE-Linux is leveraged and it has a bad policy, then it'll break all over the place and people come out with a bad experience. And then when they are presented with an option to use SE-Linux on another platform, they might say, well, no, because it was a bad experience in the other platform, so it must be there as well. But that's not really doesn't have to be like that, because if it enforces a different policy, then it might be painless. SE-Linux is generally just often misunderstood. So those are really just challenges because it's hard to get people to like SE-Linux, but SE-Linux really gives you control over your system, and that's something that is very valuable to me because I want to be able to bear responsibility for my router and my other systems in the network. But if I don't have the attributes to do that, then I feel helpless. I need to be able to control stuff in my system, and SE-Linux provides that, and that's, to me, that is just really valuable because otherwise I would be like helpless in a sense. Anyways, so the current state, yours truly currently runs OpenWrt with SE-Linux on its main router, Linux MR8300. I bought that especially or particularly to develop the security policy. I bricked it within 50 minutes after arrival, but managed to restore the thing, and it runs like, it runs great now with enforcing policy. The policy has also been tested on a Linksys WRT 1900 ACS device. That was the device that I used previously, but it has some wireless issues. It doesn't have as coverage as well as it could be. So that's now in the cupboard, but it works on that device as well. The policy has had to be adjusted actually to deal with compatibility with old SE-Linux code in BusyBox. So I mentioned earlier that we don't have to deal with compatibility issues with that one exception. In the previous slide I mentioned that. So that one exception is BusyBox. So BusyBox still has old SE-Linux code from probably more than a decade ago or whatever that actually affects the policy, because I had to work around this deprecated code in the policy, and that means that I wasn't able to leverage some of the nice features because of that. So this code should really be modernized, but I don't do C myself, and I really don't want to try because I know that C is not easy to write. I know what changes have to be made, but I don't know the details about C. So that's not my cup of tea, so to speak. So there are known rough edges that still have to be addressed. There's policy issues. For example, in LUCI, there are some aspects of LUCI that's currently not supported, like upgrading your firmware from the web interface, as well as package management from the web interface. So that works fine from the command line, but it currently doesn't work from the web interface because I have to basically make a decision there, which is just a matter of yeah, basically making the decision. It's not a big deal, but I haven't done it yet. But yeah, those are some of the things that need to be addressed. There's some other issues as well. So currently the state is still a bit rough. There was also a report of an issue on another device type that I don't have access to, where sysupgrade failed to restore the backup for some reason. Now, I would need to see some as a Linux event messages to be able to interpret what happened there. So yeah, if someone comes to me and says, as Linux block this and that, then yeah, I can't do really much with that. I would really need to see as Linux AVC denials that you can retrieve from the message, because that has all the information that I need to interpret the event so that I can make a informed decision as to what needs to be allowed, or if something is mislabeled, whether to address labeling issues with SLinux, because in SLinux, really the most fragile aspect of SLinux is labeling. So yeah, rough edges. Needless to say, there's always room for improvement.
So maybe
yeah,
this is a
go ahead.
good time to go into a real Q&A if that's cool for you.
Well, yeah, you can interrupt me at any time, but as far as I can see, I still have a couple of minutes left, and I only have a few slides left. So unless there are some basically urgent questions, then
okay.
Yeah, let me just go on to the next slide here. So going forward. So it might come as a surprise to some that I'm not pushing for inclusion of this functionality by default. I have my reasons for this, mainly experience, mainly from the Fedora history. I know how it is to push some functionality on an audience that isn't really interested in it. So instead I prefer to keep a low profile, at least for now, and instead focus on an audience that chooses to leverage functionality, because that audience is generally more open to, yeah, SLinux. If you can make the experience pleasant for that audience, then that will benefit everyone. So yeah, might as well focus on that. It will probably also help if we work on documentation and promotion. Good documentation is essentially is essential actually, and good promotion is powerful. Marketing, well, that's powerful. I foresee that there will be times where SLinux helps prevent excessive damage, and I believe it would help if those events would be documented, so that we have a reference and say, hey, well, if you would have run SLinux, then the damage would have been contained. OpenWrt is a powerful framework actually that allows us to assemble firmware for our wireless router devices. Now, the SLinux security policy is also designed in such a way that it can be assembled at build time, but it requires some integration to work to make this a fluent process. So that's something for the future that might help. So yeah, now these are some resources that I recommend. I'm not going to go through them, but I would suggest that you look at all of them. And I want to have some closing words, a call to action. So yeah, this SLinux basically needs maintenance and testing, and if nobody is using it, then it can never improve. And yeah, well, due to its fragile nature, it has to be tested frequently. And so yeah, a call to action. If you want to basically modernize access control, then yeah, please help make it better. So acknowledgement, bringing SLinux to OpenWrt is a multi-stakeholder effort. So thanks to the OpenWrt community and everyone else involved. Any questions? I'm done.
Thank you. Thank you for being perfectly on time. Now we have a couple of minutes left. If somebody wants to speak up, maybe. Okay.
Yeah, I would have a question, and So from your talk, I think that there are many details that need lots of attention in order for a potential rollout of SE Linux and OpenWrt. And how about the alternatives? Do you think it makes sense to start with smaller steps, like starting to enable multi-user on OpenWrt, just as a first measure so that we stop running everything as root? And I just know this from the user perspective, but sometimes I ask myself, okay, why would I really want to run my text editor on the router as the root user?
Yeah, exactly. I touched on this in one of my slides where I mentioned that you should leverage identity-based access control for discretionary access control if feasible. I mean, defense in depth. So yeah, if that makes sense, then use that. But don't forget that even if you use that, you still have the discretionary aspect of discretionary access control. So yeah, you can do some partitioning by associating unpriv DAC users with processes, but these processes will still have some access control over entities that they own. So they can set UID bits on files that they own. They can make files that they own world writable. So yeah, you don't solve the discretionary aspect with that, but yeah, sure, use it wherever possible. That's where it's for. As Linux is not a replacement for discretionary access control. It's an enhancement. It's an add-on.
Okay, thank you. And Deng OWRT commented that you can also comment on multi-user efforts. So maybe we'll let him take the microphone for a second.
Yeah, sure. Go ahead, Dengo.
Yeah, I saw the comments also by people reviewing and looking at the SE Linux effort saying, hey, but OpenWrt runs all those processes as root. Does it really have to be like that? Naming like, okay, so on a normal desktop Linux system, your messaging bus, dbus, would run as its own user, whereas ubus on OpenWrt runs as root. Also other like the logging, for example, also logd runs as root, ntpd runs as root. All that is basically not necessary and pretty easy to contain in most cases. And I've started doing that basically. And right now I'm like left with the network management functionality, which could also be contained in its own user. But basically ubus d runs as its own user ubus by now on a modern OpenWrt snapshot. NTPD can be run as user NTP, but for that we need ambient capabilities. And in order to have ambient capabilities being retained so that the NTPD could then actually like open port 123, which is a port less than 1024, and also can set your system time, which is both things you might want it to do. For that, it needs to retain capabilities. And for that, we have a special service, which is called procd ujail, which needs to be installed for that to work. So in the moment that people install procd ujail, also we make use of much more Linux security features for existing services where already there are profiles which can be used with that. They're all in place, and this just needs to be installed. And there's like, I'm currently suggesting to have that shipped by default because it makes like 30 kilobytes of size increase and only contains services where we have like a definition for that to be done. There are various ways to do that apart from normal discrete access control and like letting the process run under another user. Of course, there are Linux capabilities. There's also seccomp filters, which we can apply in ways quite unusual for seccomp. So there are many other options which we can all leverage in parallel or kind of orthogonally to the SE Linux effort. And I think we should be doing that.
And I agree there. I mean, defense in depth, use as much as you can. And yeah, like I said, I'm not pushing for SE Linux by default on OpenWrt, at least not now. So for the time being, using unprivileged user identities is a solution there. But also keep in mind that you're still dealing with discretionary access control. You still have the privilege escalation, basically inadequacy that you have to address. And also you mentioned that you can use ambient capabilities, but that's also a point there. So now capabilities are also a thing for unpriv users. So yeah, SE Linux can basically contain all processes, unprev user processes or prev user processes. So if you start to leverage ambient capabilities, it makes that much more sense that you contain that all with mandatory access control on top of that. So yeah, it complements each other in a sense, I would argue.
Okay, there was a question or a comment from Hauke.
Yeah, regarding these topics. What do I still get the advantages of SE Linux when more or less everything is running as root? So there's still some restrictions?
Well, totally. I mean, as a Linux, the less user identities you have on a system, the more sense as Linux makes, because if you think of partitioning the system based on user identities, then it means that more than one entity in your system is associated with the same identity. Now, in a system that has only one user, where the user is root, that means that your whole system is not partitioned. There's only one partition, which is the partition based on the root identity. So in that scenario, as Linux makes the most sense, because any process, any entity in your system can compromise the whole thing. So think of an as Linux enabled system as a submarine with compartments. And the idea is to basically contain a leakage to a particular compartment so that the submarine as a whole does not sink. That's the whole goal of it. So, and it also makes it easier to restore the system because you know that the damage is contained to a particular compartment. So you can focus on that compartment, you can replace it or fix it, and then your submarine can go on and on and on. So with a single user system, that is actually, as Linux is ideal for that.
Okay, another question. In the Max system, is there each entity? Does it mean each process is its own entity? And does it get the, so each process is then contained by SE Linux, or how does it work in general?
So I mentioned in one of my slides that SE Linux that Linux is essentially, that in Linux, essentially everything is a file. So a process is essentially represented in a Linux system as a file in the proc file system, the sudo file. So everything in a Linux system is a file. Now, I'll just translate that to an entity. So everything is an entity. So as Linux enabled system, we treat every entity as its own entity, whether it's a file or a process or a network port, a network interface, even a network packet. We can treat them individually. So we can associate permissions with every individual active entity to access every individual passive entity. With a passive entity, I mean an entity that doesn't do anything, like a file, and an active entity is a process because it actually operates on a file or interacts with another process. So yeah. Does that answer your question?
Yes, yeah. Thank you.
All right. So yeah, thanks everyone, and thanks to the organization, and yeah, I hope I enlightened and clarified things a little bit so that people are more open-minded to at least try it, and just keep in mind that as Linux does what it tells you to do. It gives you control over your system, and you shouldn't fear that. But yeah, obviously with power comes responsibility, but you shouldn't fear that, and be happy that you can control your device, I would argue, because you run software, lots of software written by strangers, and yeah, I want to eventually be able to control what that code does on my system because it's my system and I bear responsibility for it. Any other questions or not? Otherwise, I'll pass the mic to the organization.
One short question, how much extra RAM and flash does it need when I activate it?
Right, so that's a good question. So overhead, by using the immutable policy, obviously the resources are a lot less than if you use a mutable policy. But by default, if you install OpenWrt with as Linux enabled, you end up with a policy that is around and about 150 kilobytes to 200 kilobytes, but then you get support for LUCI, which is quite expensive. So that's basically footprint on the storage device, as well as probably it'll get loaded in memory. So yeah, probably also 200 kilobytes in memory. And on top of that, you'll also have the dependencies like SE-Linux user space, which adds, well, I suppose maybe a couple of megabytes. I'm not sure. Dango might be able to tell us how much the SE-Linux user space takes of storage. And then you obviously have to enable some options in the kernel, but I think that's probably negligent there. So yeah, I would argue if you have a modern wireless router, then you probably won't notice much storage-wise and memory-wise, as long as you don't use a mutable policy. Because if you have to compile policy, then you're gonna need memory and you're gonna need storage. But currently, that's not applicable, not an issue.
Yeah, compared to reference policy, like reference policy, if you compile it, then the policy alone is already 3.6 megabytes compiled. So that's a huge thing. You can't really do that on a like small embedded device. With Dominick's policy, basically, we have like a total of around about 0.5 megabyte of total flash being taken. And I'm talking about both like increase of kernel size due to needed kernel features, plus total increase of the squash FS, which includes all the user space tools and the policy itself. And apparently we need something similar among those lines in memory. Could be a bit more if you make real use of it, but like we're talking about like a megabyte, maybe not more than that of RAM compared to not using it.
Thank you.
Okay, thank you.
So, Philipp, you want to take over?
Are you talking already? I can hear you.
Where's the audio? Just a sec.
Can you listen now?
Yeah.
Sorry. I'm sorry. So I was saying that this is a quick wrap up for the first day of the wireless battle of the mesh in this virtual global edition. So as I was trying to say that we had 80 participants over Big Blue Button and YouTube, which was a great surprise for the organizers, because yesterday we were about 30 people that were registered, and then suddenly we had more registrations this morning, and finally we had this 80 participants, which is very good. And I would like just to have this 5 to 10 minutes to ask what do you think about this format, these platforms. We also have 1 day more for the event, so we can change something, but I would like to have your feedback if you have one.
Just grab the mic or type in the chat.
So we can have a little bit free time now, something that you wanted to discuss or to raise up here.
For us, it's also pretty interesting how it felt for you when you joined during the talks, and whether you found all of the information that you needed. If maybe the small room on Jitsi needs more advertisement, or how else we can help you to enjoy your stay and make you participate in the conference.
For me, I had a big fear that this will be just another online conference where I don't have any drive to attend. But in the end,
it worked quite nice for me. So even my first glance at the schedule was only 3 hours or 4 hours. I thought, okay, this is a bit different from what I used to have at the Battlemesh. But it's good. It's better than not having anything.
Yeah, that was the decision to be made. Either we could do something, even if it's a couple of days, just a simple event that everyone could attend in a simple schedule. And so one suggestion was to make a break between presentations. So maybe we can try to at least get some 5-minute breaks for a coffee. That, sorry, we couldn't get you some coffee this time. So we have made our own coffees. That's one of the downsides. Okay. So other thing that I'd like to highlight is there is a slot for 2 lightning talks tomorrow. So if you'd like to just have 5 minutes or so presentation, just to raise some question or something that you'd like to show, feel free to submit a proposal for this. Just send us an email and we can add to the schedule. Other thing is, it would be great if you could take a picture even today or tomorrow or both of the days. So if you'd like to just open the webcam, we could try to make some pictures.
Server handle that?
Let's test it. How can I? Okay, so I quit the presentation.
Let's crash the server. Handle it.
Let's do a test.
Crash test.
No, you.
Hello.
Everybody turn on full HD streaming, please.
So we are 42 people here, plus around 15 on YouTube. So it's
Text file is on the submarine already, so he's
in the red light.
I actually liked what the DebConf did. They said, please everybody take a picture in front of a white wall, and then they meshed it together. So cropped everybody out and put it together.
Okay. So while people are still connecting the cameras, let me just finish this slide. So for tomorrow, you have approximately the same time for the talk. So we start at 3, that's Central European time, and we finish around 7. So these are the 2 slots that we have at the moment. So feel free to use them for sharing something. And yeah, finally, thank you to you all attending, and thank you for all the presenters that made a great job in doing this presentation remotely. And yeah, so maybe I can now put this aside. How many are we? We are 16 at the moment. Okay, so it's holding up. Hello, very nice faces. Long time no see.
Yeah, I think it worked very well. I was not having high hopes when I looked at the agenda mid of this week. I thought, sounds boring, but actually it was really cool. So yeah, thank you to all presenters. It was also very interesting. Yeah, I also would agree to the short breaks. That would be good. I think I don't know how many applications you got for talks, but for me, just having 3 or 4 hours on 2 days is more than enough right now. What I can handle from home, so that's also good.
Okay.
Certainly enough for me.
Yeah. So this is very strange to be in a virtual meeting, especially for Battlemesh, where people were hands-on on the equipment and full week, like 20 hours a day. So this is really different, but hopefully it went okay. So maybe you can take the group picture. We cannot move very fast, otherwise we'll get very blurry. Okay. So on 3, 2, 1. Okay. So I can later share the picture with you. So thank you for the first day. I will see you tomorrow. And have a great night. See you.
Thanks, everyone. Great
All right, thank you.
Thank you.
The mini Seaman.
Zeig mal, was du gemacht hast. Zeig mal, was du gemacht hast. Hm? Zeig mal.
What did the kiddo do?
I don't know.
Project. It's great.
Ja, soll ich dir mal helfen? Komm hier, komm. Guck. Ah, warte. Oh.
So for the YouTube channel, I will see you tomorrow.
Yeah.